I don't really know who's on the call anymore.
I am.
Oh yeah, Rav,
Hi.
you're there, right?
Yes, yeah. I think someone's.
Can you hear better now? Because we are definitely tapping into mic levels at our end on StreamYard.
Yes, yeah.
Can you hear better or? Yes?
Maybe I think an exercise that we do is you keep saying something. Just keep
Yes.
if you want to keep reading something, keep reading it, not a problem, and repeat
Okay.
till we catch the audio levels. That's it. Yeah.
Okay, perfect.
Okay, we can start that now. Rav,
Yes, sorry. Is someone going to do an intro?
Christian is going to be reading something now as a test reading or something, and the idea is that you can
We're on
maybe
live stream. I think someone's pressed the live stream button.
yes,
We're on live stream.
yes,
Okay, so we're still testing.
yeah. I don't know why, why, but I mean, we were we were just back there, and of course, like I mean, Martina and Clemens were also checking this, and they were like, I think it's time, and we should be live.
Oh, okay.
So the idea is, Christian will just read something just now in front of you, and if you can
Yes,
just tell us
absolutely. Yeah,
if
yeah,
the audio
absolutely.
quality is fine in terms of actually having the mics, that would be perfect. So maybe you can just start reading something.
Okay.
The manual microphone is still very quiet.
Yeah, I just checked that quickly.
In StreamYard, use the share screen option at the bottom and extend your screen while sharing. If you use PowerPoint, use Presenter View in Tab, Slideshow, Referentenansicht in Tab, Bildschirmpräsentation to see your
Yes,
notes.
Chris, we can hear you. But I can also
Okay.
hear a lot of yes, but I can also hear a lot of background in the back.
Yes. Yes.
Yeah, there's actually a
It's
lot
the
of people
audience,
who's
yes.
yeah. They've just
Okay, yeah, we can hear you. We can hear you.
Perfect.
Thank you.
But I don't start.
Thanks, Rav.
What time are you? When are you going to start? Because we're on the live stream now, and there's about 22 people live.
Maybe we should ask Martina. Martina, when are we planning to start? Now, actually. Now-ish. Like I would give it maybe 5 minutes, and we're good to go.
Okay, so I'm going to take you all off the stream now,
Yeah.
and then we'll come back up.
All right.
Yeah.
Thank you. Yep. Yeah, now it's good.
All right.
Soll ich dir noch Pfefferminztee machen?
Bitte?
Soll ich dir noch Pfefferminztee
Das soll allein, ich habe von Döner gegessen, sorry, das liegt von wahrscheinlich.
Ich dachte wegen des Hustens.
Nee. In aller Schnelle noch reingestopft.
Okay.
Nachdem es Bob ist, war auch aufgefallen.
I think we can start.
Yeah, I think so too. Okay.
Maybe now.
Yeah, if we, you start the
It's already started, yeah.
And the code of conduct?
I think the code of conduct is what is up.
Okay, no worries. Then we'll just fangen wir einfach an, oder? All right. Hi, everyone, and again, thank you for being here. So I guess we'll start. We're already running a few minutes late. Welcome to our second official Microsoft Reactor session here in this Kinfolk office. Very happy that you all had time to come here. You've probably seen what we're going to do today. We have, I think, 4 sessions in the area of cloud native and Azure best practices. So stay tuned. And we'll start with our Azure Developer Community Call, which was originally a Teams call, but we now are going to integrate the session into the Reactor just to make it more available on the streams and also for you, because I think the topics we present in this call are quite nice. So in this call, basically, we are going to show a quick update on the Azure Developer Community 2.0. We're going to present some community news, and then we'll come to a few service updates and announcements before we actually go to the focus topic, which is not Java on Azure. Sorry for that. It's actually domain-driven design for highly distributed systems by Leinweber, who is sitting here from MaibornWolff. So sorry about that. We're going to correct that for the upload. And quickly, we're going to share the code of conduct, which is both for the developer community call as well as the Microsoft Reactor. We are going to, or we want to have an inclusive environment, so we hope that everyone here is respectful of each other. We do not tolerate any disrespect or harassment of any individual, so please, if you notice anything, let us know, and we'll keep the right to basically do the right measures. So for the community 2.0, we basically just have a short update. We have this call now in 2 forms. One is this one, which we're having right now, where basically a subject matter expert is going to present you a specific topic. And the other one is the Ask Me Anything session type, where we are going to invite a subject matter expert, and you can just basically do Q&A with them and ask your specific project, specific questions, for example. So we also have the Azure Developer Community Hub on GitHub. So if you want to contribute, you're very, very welcome to do so. So just go to akms/AZDevHub, and you're going to find the repo and hopefully also some helpful content. And if you ever come across something which is nice to know for a developer in Azure, remember to contribute it as well. We also have a LinkedIn group. So where the GitHub repository is mainly for sharing resources. The LinkedIn group is basically to stay up to date for upcoming events like this one. So there's we're going to push event notifications there and let you know about upcoming stuff. And just a quick notice of past and upcoming events. So this week we actually had the Azure Developer Community Day in our office in Munich, so in the Microsoft office in Munich. We had 4 parallel tech tracks, as well as 30+ sessions and speakers, and more than 100 attendees on site. And if you want to see some of these sessions, you're invited to do so. I think they're going to be published soon on YouTube. And for upcoming events, I'm just going to quickly share the 2 for the community calls. So in January, we'll have an Ask Me Anything session on applied serverless architecture patterns as well with Christian and our host, Dennis. And on January 19th, we're going to have the next Reactor session here, which is all around .NET. And as part of this Reactor session, we'll also have the community call on .NET MAUI, presented by Torsten. Yeah, so the next 2 Reactor sessions, I just mentioned it. January 19, if you're a .NET developer, that may be interesting to you. On February 16th, it's going to be a mixture like today of different Azure sessions. So there's no focus topic yet. If you want to present something, you're very well invited again to let us know and also present something that is of interest to the audience. And with that, I'm going to pass over to Clemens, who's going to present the Azure updates.
Yes, I will. Friends, good evening. It's awesome to have you here in what I consider the optimal amount of participants during the coming Christmas time. This looks like around, I would invite for tea, and we actually do have some tea with us. What we also have are some of the Azure news and updates. First thing, who of you took part in the in-person or online community day that she just mentioned? Did any one of you join, actually? Oh, that's a pity. Do that next time. So first things first, we have an announcement to make regarding the Azure Backup Service. The new feature allows you to backup and restore containerized applications, both stateless and stateful. It also works for backup orchestration and can be used alongside our backup center. You can request access, as this is a private review feature, starting right now by filling out the form on the aforementioned link, aka.ms/devops. Make sure to check this out if you haven't done so yet. The second new feature is especially important for read-heavy workloads. It's about Cosmos DB or Postgres, and it now supports cross-region asynchronous replication between clusters. This helps load balance across independent read-only replicas, and they can be promoted to independent read-write clusters now. Another one for Postgres, to save you some time with your data upload pipelines, using the PG Azure storage extension, you can now interact with Azure Blob storage containers directly from Azure Cosmos DB for Postgres. Container content can now be listed and fetched using the copy command, and we have included a flexible API on that one. Speaking of Blob, Azure now offers the capability of mounting Blob storage, or for that matter, object storage, as a file system to a Kubernetes pod or application with Blob Fuse or NFS 3. I feel like this might reduce some operational overhead and maximize the time to value. Not only that, if your application ingests data into a data lake storage on Azure Blobs, you can now directly mount and use it with Azure Kubernetes services. Apropos SQL, there is a new trigger in Azure SQL for Azure Functions that is now available in public preview as well. So via request for C#. It is compatible with Azure SQL Database, Azure SQL Managed Instance, and Azure SQL Server. The function can be invoked when a row in a SQL database is created, updated, or deleted, whatever. The trigger is compatible with the database, the managed instance, and the server, as I already said. And we have a prime. Azure App Service now natively, finally, I have to say, supports Go. The language support is available as an experimental language currently, released on the Linux App Service since 13 days or so. For the first time ever, it's available in version 1.18 and 1.19 in the Azure App Service. We would like to know whether this worked for you, so feel free to provide feedback if you use it. And the last update for tonight is that Container Apps now supports a new Azure Pipelines task in public preview as well. The task builds and deploys container apps from Azure DevOps, basically. By integrating this task to your pipeline or workload, you can enable continuous delivery of your code to Azure Container Apps. The GitHub action, that is the second part of this update, basically, builds repo content into a container image, pushes it to the container registry, and deploys it to Azure Container Apps as the image shows. The good thing is, even if you do not include a Docker file in the repository, the container image can still be built as long as it is in one of the languages and runtimes we support, which is .NET, Python, and Node.js, as far as I know currently. And with that, we go to the first hot topic of tonight, which is domain-driven design for highly distributed systems. Welcome, Christian.
So
That's some loud boots.
So, welcome to my talk. I'm Christian Leinweber, and today I speak about domain-driven components on fine-grained application architectures. I think this sounds a little bit heavyweight. Maybe it is a little bit heavy, but it's just my motivation to share some community stuff with you. Community means I and my team discussed a lot about architectures, about ideas, and so on, how we can bring back more domain focus on a very technical driven world like cloud native applications and so on. And we had a lot of discussions internally. We try out things in projects and customer projects. And this is just about knowledge sharing with you, what our experience are, and maybe it's an input for you, a discussion point, and we can discuss together at the end. Yes, that's my focus on the talk, just review what happens in the next minutes. So first, some words about me. I'm Christian Leinweber. I'm principal architect at MaibornWolff. I live with my wife and 3 kids near to Lüneburg. This is by Hamburg. So I'm located in the office location in Hamburg. I work from there, I think, two times a week, the rest from the home office. And yeah, I work mainly on Azure applications the last year, I think. So with my team, we built for different customers cloud native applications. MaibornWolff itself is not just focused on Azure, but I personally work for the last years in Azure projects, mainly with a focus for IoT. Yeah. So some words about MaibornWolff, some short words. So we are a classical developer consulting company who builds 100% individual software for customers. So we're not a product company or something. We just build software for customers, and we are divided in some departments like mobile development, data, AI, cybersecurity, and so on. And if you're looking for me, I'm here, maybe you spoiled me. I'm in the DevOps and Cloud Native department. So we like to automate stuff, build stuff around pipelining and Cloud Native applications and so on. Yes. And at MaibornWolff, so from the early days on, we have one all-time question, and this is how to ensure quality over project borders. So we had a lot of customer projects. There are big, there are smaller. We have a lot of movement in teams. We have new junior developers. They became seniors over time, but there are a lot of movements in our projects. And the idea or the question every time is how to ensure quality, what learnings will we have in one project, how we can transfer it to other projects, how we can make standard ways to solve something. And some old wise architects told me that it looked like this, I think. I don't know if it's true, so I'm not at MaibornWolff from the early days, but there had a lot of discussions about architecture and how we solve something and so on. They make drawings like this. This is a very, very old picture I found in our intranet. Yes, but the result of all these discussions were a guide. So, and the guide in English is an architecture guide, but in German we say Architekturleitfaden, and the shortcut for this we call it ALF. Yes, so in MaibornWolff term, ALF is this, and ALF is an architecture guide with a lot of PowerPoint slides with best practices over projects and so on. But this ALF has one thing in common with this guy. Yeah, so both named ALF, and in common, both are a little bit old and old-fashioned. So this guy from the TV show, but also our ALF is a little bit old-fashioned. So what we do or what we decide is we want to write a new guide to focus more on cloud native Azure or cloud native architectures and so on. So we started with that, but as we started, the question came, what has changed? Yes. So what differs from the classic way to build monoliths? What is the difference if we build cloud native applications and so on? And if we look into our projects, we realized that one example, what has changed is this. Yeah. So in former times, a lot of architectures and monoliths use the classical layered architecture. Yes, you have your business layer, you talk with your DAO objects, with your data layer, and so on. And this is part of our ALF, yes. But if we look at our current projects for customers, a lot of teams don't use a layered architecture anymore. It's nothing against the layered architecture. Yeah, it makes sense to use it in some ways. But if we look in some projects from us, a lot of people use a kind of hexagonal architecture. Yes, you can call it onion architecture, clean architecture, whatever. But every teams or a lot of teams use this. So the next question is why? So why so many teams choose this type of architecture? And I personally think it's a matter of this. Yeah. So if I look on the layer architecture on a monolith, I speak mainly to my database. Yes, in this case, I also speak to external services sometimes and so on. But I think if you build cloud native applications, the amount of external resources keep growing around a service. Yes, so you have to interact with more services. You have to interact not just with your database and so on. Yes, and I think the hexagonal architecture type supports this very well. Yeah, and the other thing it's a very domain-focused approach. So you can start from your domain have some requirements about the ecosystem, and don't know directly external dependencies. They don't know some kind of DAO objects or have a direct dependency to a data layer and so on. And I think this is a reason why teams prefer to choose some kind of this way and not the layered style. So then we looked on another question, are there still aspects that are still valid in our old ALF? And yes, there are a lot of points that are still valid. And one example, I think, a very important example. So I have a slide with me. Yes, this is a German slide because I don't have a translation for this. This is directly from the ALF. But the key is that domain aspects should design components. Yes. So not technical influences or technical boundaries should design my component borders. It should be a business case. So this is not 100% true. There are still points that it makes sense. You choose your architecture style because of technical influences and so on. But I think in common, this is a constant that it makes sense to build software around your business domain and model your components around it, and so on. And I think this point is still valid just from the ALF. And if we transfer this both points to the microservices world, it could look like this, yeah? And maybe you know it from your applications you build. Yes, this is an architecture for microservices, and you have one and two business domains. Maybe there's a little box above this, but this is business component 1 and business component 2. And with microservices, this works pretty well. So you have a domain aggregate. You can build a service around it. The service is independent from another service. You have an adapter layer. You can talk to different kind of resources like a message bus, or you serve some API endpoints with your microservices, and so on. So it fits very well to an hexagonal architecture, and it fits very well to build your software about business components, business aggregates. I have one example with me from one project we built up on a classical microservice approach. Maybe you know it, yes. This is, maybe you have used it. This is a screenshot from the Navigator app, and our project is directly behind this little button. So I don't know if you know what happened when you click on the button. A lot of people think this is an icon, not a button. But if you click on it, you can see where you have to position yourself on a platform if you're waiting for your ICE and so on. And you can see, okay, my door is directly on platform A, and I have to wait there. Yeah, and if the train make a make a direction change, you know, okay, I have to jump to the other way over the platform. Yes, and the ICE is about 400 meters, and it takes time to go from one end to the other end. Yes, and this system behind that we call virtual train, and is directly a microservices system. This is a very, very old screenshot, as I were part of this project, but it doesn't matter in detail what the system currently do. From the DNA, it's a data pipeline. You have a lot of data sources, we collect a lot of data, and in the end, you get something like a twin for each ICE, for a regio train, or whatever. And this is built on microservices, and every service do something with the data and give it to another service. So a classical data pipeline. The other point, what you can see here in this picture, is there are groups or boxes, yeah? Green ones and gray ones. So the green ones means this is a service group who are suitable for not just for an ICE, just for other trains. Yes, it's a common service group. The gray ones are specific to an ICE or whatever. And what we can do with the system, it's like a building block system. We can say, on a service group level, we put things together and have a different outcome. Yes, so we can make individual data pipelines and produce individual outcomes for different train types and so on. So, but I don't want to deep dive in this project. So if we came from the domain-driven design, how domain-driven design help us in this project? So that's the next point. As we start with this project, we had a lot more microservices, as you can see here in this picture. Yes, and if this was very, very fine-grained application, and if we see one use case, or if we want to understand just one use case, we had to click into 6 different microservices just to understand what this one use case do. Or if we change one use case, we have to deep dive in multiple services to make a change, and that don't make sense. So it really don't make sense. So what we do over time, or what we did over time, we put services together to focus on a group where we say, okay, this service is suitable for exactly one use case and have a boundary and so on. He produced some output with some contracts, but we don't split the domain boundaries over multiple services. And this was a big learning inside this project. And then we are able to build the stuff with the building groups and so on. Yes, so we were very domain focused in each service, and this helped us a lot. So, but if I look on current projects, so I have another example. It's getting more fine-grained. Yes, so the microservices stuff was very easy to build around domains. But in this example, this is an IoT project from me and my colleagues. I don't want a business deep dive, but it's all about measurement of gases in the air and alarms and so on. And we produce some apps. They collect data from devices, put it in a big cloud backend and so on, completely based on Azure functions, on serverless functions. We produce the outcomes of the measurement stuff into Google Maps, so everyone can click on this map and see there is a worker, there is a dangerous because there's an alarm and high measurement volume, a high gas in the air and so on. And what we do with Draeger together to build more stuff. So we build together with Draeger IoT edge devices to collect alternative data streams and so on. But all are consolidated in the same backend, in the same serverless application. This is growing over time. And the architecture idea looked nearly like this. So it's easy to start from the left and go to the right. So we collect on the left side data about IoT stuff. We collect data about the mobile phones and so on, and all come together on an event hub. And we had a lot of handler functions who react on data which came over the event hub. Yes, and there are the business logic inside. they produce outcomes, read models, store it in a Cosmos DB, in a time series DB, or whatever. And we have an API layer which HTTP triggered functions above. Yes, this is our architecture idea. If you look in a real diagram, we have, I think, currently about 100 different functions running in this cluster, not just handler functions or HTTP functions. It could be a timer function who clean up some data and so on. So much more fine-grained applications than we built in former times with microservices. Yes. And the question that I have, why it drifts in projects in this way, why it get it more and more fine-grained, especially on cloud-native applications. And I personally think it's a natural shift, yes, because if I think about cloud-native applications or if I build cloud-native applications, it's all about costs, it's about resource usage and so on. Resource usage came with sustainability and so on, yes. So as an example, if I have a handler functions or one handler function who react on an async message, I don't want to spin up a microservice maybe based on Spring Boot, which serves some API endpoints just to compute this one message. Yes, and I want this compute message and give the resource, the cloud resource, free again. Yeah, and the other way is also true. If I have an HTTP call coming in, I don't want to spin up some resources to receive RabbitMQ data or whatever. Yes, I think this is a normal shift why it get it in cloud native applications more and more fine-grained. So on the next slide, we make a deep dive. So it's look like the microservices picture from the other slide, but it differs a little bit. So we have two domain cores here. We have two function projects. Both of us reads the database and so on. But if I remember the microservices picture, I have two business components, business component I and business component B. And these are not two business components. Here we had a technical motivation for a split. Yes, the technical motivation is we need a handler for messages and we need an HTTP trigger for my HTTP calls. So this is not a business case why we have two domain cores. But yes, I have a split. So if I say this is one domain, I see here two cores, and this maybe leads to code duplications. This maybe leads to dependencies between these services and so on, because they use the same data store. One handler function stores data, the other function is for HTTP who read data. Yes, both use the same store. They have the they have the equal models maybe and so on. Yes, and what can you do? Yes, for sure. You can build up shared libs between these both components and say, okay, here are maybe my shared models and so on. But if I remember on the best practices for microservices, we don't really want shared models. So we don't want a version lib where we can push something inside the registry and so on and pull it on the other service. It doesn't make sense. Especially here, we have one domain. Yes. And if we look on the data store, both of it read data from the same store. And from the microservice perspective, this is more like every microservice should their own data store and not sharing the data store with other services. Here, I think it makes no sense. Yeah, it's not possible because you have a reader for the data and you have a writer for the data. Both of it needs to connect to the same data store. Yeah. So my conclusion, or the conclusion for our team, was very important to don't see one function project as a closed business campaign. So it is not a closed business domain. So it's a technical approach to do things. And the other question, if we don't have closed business domains or business components, do we need no rules? So then should it be possible that one handler function connect to every database, to every data table, or talk to every HTTP function, whatever? I think no. So in microservices, you build communication rules and so on. And the first step, what we do to solve this problem, we introduce some kind of virtual component. Yes, we can say, okay, both of these functions are grouped together as a virtual component. Yes, and if I zoom out, I can do this with other functions. So I can make groups. So I can say we have a business component A, a virtual component, and B. And we can say that each function inside the business component are allowed to talk to a data layer, but are not allowed to talk to another data layer from another group. So the same rules you can set up for microservices, you can reuse for virtual business components. You can set up rules inside these very fine-grained ecosystem. Yes, or you can say, I only want async communications between these virtual models, exactly like in microservices. You can put the same rules on it just to define it as a group. What we did, for example, you can now just draw component diagrams with it. Yeah, this is just a small snippet of a bigger diagram, but you can say you have a group, and this group of functions are allowed to talk to this worker states in this example, and you have defined contracts how these components interact with each other. So you have a little bit structure in it. But this does not solve this problem. Yes, you have still two domain cores, you have still a split inside your business component, and this should be solved anyway. So the communications rules are fine, but we have the same problem with the copy things about stuff like models and so on, dependencies between this. And for this, we created another solution for us. And we try this in projects, and it works very well for us. So we do this. Yes, we have a virtual component, and the first step is we create a single domain core from it as a package. Yes, not a version package what we push, but we do it with a package structure. And if you look exactly in the circle, they are missing the light blue circle. Yes, the light blue circle is the way this is the application layer inside a hexagonal pattern. And this is just the domain and the adapter layer for communication for the databases and so on. So what the next step, we split the domain core from the application layer, which means the gray ones are runtimes, function projects, maybe you can start and so on. And this means the application layer is just an entry point to the domain. Yes, you have an own application layer for HTTP, maybe for messages or other inputs, whatever. So it could be a timer, something else, but the application itself has no logic. It's just an entry point. It's the main code if you want, and having just one call inside the domain gets a feedback and give it as a response for an HTTP AIP or whatever. Yes, and yeah. And now we have both. We have a single domain. We have one position where we can change our business domain, but the application trigger can scale based on messages, and the HTTP trigger can scale about HTTP stuff like that. Yes. So I told you that it is an anti-pattern to build shared libs and so on, but this looked like a shared lib. So what we do is we structure our repo a little bit. Yes, it works on multi-repos, it works on mono repos like you want. So the key is that you put your virtual component as a top layer. So the top layer describes your virtual component, and you can make a multi-repo per virtual component. You can put it as a top level in your mono repo or whatever. And you have, or we build it in this structure. So we have a domain package, and we have another package for every application around this domain. And the trick for us is to include the other package within the build time. Yes, so you can do it with Docker builds or whatever you use. If you import it in build time, you copy the domain code in the trigger and have a closed application. Yeah. So yes. The downside, maybe this is a downside, if you have a change on the domain, you reproduce all your applications every time. Or you have a change on the HTTP trigger function, you reproduce every time the same artifact for your event trigger. But I don't think it's really the downside. I can live with that with my team. So this structure helped us a lot in a universe where we set up 100 functions and more. Yeah. It works like this way. So you don't have to put every application layer in a separation. You can group it together. So you can say, I have 3 different HTTP triggers. Yeah, one for post, one for get, one for whatever, for delete. And you don't have to do it in a runtime. Yes, you can group it together if it makes sense to you. Yeah, so and this is what we do. We group all our HTTP triggers together and run runtime, can scale it differently from our messages they're coming. Yeah. And another point, it just works for everything. It's not only for Azure Functions. Yeah. In another project, we set up on container apps, so more on serverless containers, and the same pattern, or we could apply the same pattern what we do in the other projects with the functions and so on. But as I said at the beginning, these are still tryouts. We try it in customer projects. Some things work very well. Some things we have to adjust a little bit. But this is just thoughts I want to share with you. So in summary, what we did so far, we introduced the new architecture patterns over time. So like I said, then we find a solution to bring back a domain-driven input or domain-driven design back to very technical cloud-native applications. We set up virtual components to create communication rules between different groups of fine-grained applications. And we split the domain core from the application layer to have one core and scale up different things independently. Yeah, and all this stuff, we create a little write-up on GitHub. This is just on draft. It's far away from ready, but I share some thoughts of the design about our discussions there and other stuff like an overview for infrastructure architecture in cloud applications and so on. Yes, this is from my side. Thank you very much and for your attention. Maybe you have questions, I think. Yes.
Yes. What the cost of splitting up monoliths into components?
Oh.
Can you always repeat the question?
The question is, what about the costs about splitting up monoliths into cloud native components, whatever. So yes, I think it's a very hard question to answer because we don't start with a monolith in this case. So this examples where we build on greenfield new projects, but I think how expensive if it is to split up a monolith, I think you can build your own talk about it. So you need a concept depending on your team, depending on your size, depending on the age of the monolith. There are so many aspects, so it's very hard to give you a cost number about it.
Do you have any tools for documentation or for automated documentation? For example, if you insert a new function somewhere, so that it gets integrated to the documentation and tests.
My personal, so I can repeat the question. The question is if we have some kind of documentation for if we put a new function on it and how you can document it. Have you tools for it or something else? And I personally like, and my team, I think also, that we create architecture drawings just for sharing ideas, not for be 100% correct that every function is on this. So there's a lot of movements inside this for documentation part. So if I can add a new function, we use in Azure application maps. So with application maps and some instruments, you have a good overview about the whole architecture and so on in a live view. Every function, every new function you can see on it. What we additionally do, we write readmes and so on in every function step and so on.
Is there a smooth path from migrating from a monolith or some architecture to microservices?
I think there are a lot of paths. This is some smooth is yeah. I think there are some patterns how you can shift from a from a monolith to a microservices. Yes, some facade patterns and so on that you can have both over time and split some logic out of it and put it in a smaller service, but your facade is just a router for the old one or the new one and so on. Yeah, but there are a lot of books around these topics. Yeah, it's very complex.
We've got one question from YouTube. I'm not absolutely certain I understand what it means. I'll ask it in German because the man did, and then we can translate. Muss das Gerät mit der Domain verbunden sein oder als Kundenendgerät?
It's hard. I don't understand the question.
Okay. Yeah. Same for me.
What means device? So yeah.
I don't know. I will just connect you to the guy who asked, so perhaps you can reach out on.
Perfect. Yes. The architecture example from our IoT project, there are devices in all this ecosystem, yes, but all the stuff about the virtual components, the functions design and so on has nothing to do with real devices. Yes, we set up devices together with Rigor on IoT Edge to run containers on the edge and so on, but these are device projects, yeah. But I don't think it had anything to do here with the structure about domain-driven design. You can use the same aspects on the edge. True, yeah. Yes, I think no more questions, maybe online, but then I give to you.
Actually, we have no more online questions, so thanks a ton. If you wondered where this man came from, he actually traveled from Hamburg to tonight to be here, so please give another warm round of applause. Make sure to follow on LinkedIn and on GitHub, obviously.
Yes.
Martina, do you want to... just two comments. So the next session will be from Marcin, who's already in the background, so stay tuned for that. Just a logistics thing, if you want to use the restrooms are around the corner through that door. Even during the presentation, we're all here to connect, so feel free to walk by the speaker and just use the restrooms whenever you need. And with that, we have like 8 minutes break until the next session, so grab a drink and ja.
Es gibt einige Fragen bei YouTube. Vielleicht magst du da nachher machen.
Ja.
Super cool, danke.
Ja. Was hast du gesagt? Einige Fragen?
Ja, genau.
Ich sehe die online. Ich sehe die im Dings nicht. In dem YouTube irgendwie keine Kommentare.
Vielen Dank für die Insights. Ich habe natürlich böse Fragen gestellt.
conferences, but then we also hire AV teams. So they take that, and this is what we have, right? I think maybe I have to say something. Yay! Is it working? Yes. Yeah. So Marcel, as you can imagine, so I would just like maybe pinch my shirt a little like this, and then put it something like this. Yeah, yeah, that's actually perfect. I'm trying to go away. They're writing with a lot of paper. Yeah, that's okay. All right. Okay, I guess
Okay, so I had the green light. I will start. My name is Marcin, and today the topic for the presentation will be touching security topics in the cloud and also code. So it cover kind of both worlds. Hopefully you find it interesting. So I would like to present you and describe a little bit how we build a software that actually scans the EIC, the cloud, and also code for vulnerabilities, misconfigurations, also secrets, also leak secrets, and also malware and crypto hijackers. And it's pretty much very it covers different areas. It's called better scan. So as you know, as you hear in the news, we hear all the time about the misconfigurations that cause the breaches, also that expose S3 buckets, Elasticache, Elasticsearch databases, different databases, also bugs in the code, or expose secrets. And the problem actually is due to misconfigurations and sometimes lacking of basic automation in prevention of this. So and those vulnerabilities, they actually top the chart. I'm working also in the industry of security, so this is the stuff I always like hear. Misconfigured S3 bucket caused this leak or secret leaks. So what are the problems?
Marcin, just 1 second. Sorry, the digital audience cannot hear you well.
Okay, sure.
Can we use this one?
Yeah, of course.
Even though, sorry, I'm sorry.
No worries.
You have to switch it on, I guess.
Okay, sorry.
And then maybe we'll switch this one off.
Yeah, sure.
So
Yeah, sure,
it
sure.
doesn't.
Doesn't keep it.
Yeah. Thank you very much.
No worries. Okay, I hope you can hear me better now. So what are the problems we try to solve? So as you know, you need a real security that is made in a consistent and continuous way. Sorry, just really make my laptop. So you need a real security. That's obvious. But the other topic is that very important topic is the compliance. Now, as you know, we are since 2018. There's a requirement in Europe for GDPR compliance. Also in US, in California, there's CCPA. It's equivalent to GDPR, European GDPR. And also there's like other compliance standards like SOX, also PCI DSS for payments. And soon there's regulations for IoT devices that I think it's called Cybersecurity Act or something similar in the US and also in Europe, that each IoT device has to be has adequate standards of security in code and also in the configuration of the device. So those are two problems we're trying to solve. And you need both to do the business. Real security and compliance, they tie together. So then you also think about, hey, I have a code, I have cloud, I'm a startup or a small or bigger organization. I always have some code in the cloud. So I will need to have a solution to cover the misconfiguration in the cloud, then to look for a solution that covers the code. And most likely you end up with some proprietary, very expensive solution that is closed source. You have to just get the binaries, run them, or integrate via some kind of API key to the third party. And you cannot do anything there also. So also you think about, hey, what about secrets? What about binaries? Like, let's say if somehow there's a binary that will sneak in to your code base that has some malware in it, like cryptojacker or some kind of APT, advanced persistent threat code. So if you want to do also secrets and binaries, you need to look for other solutions. And this, when you also have multiple vendors, you have to trust them. Also, your supply risk increases. So, as you know, like this is a big actually it's a good question. Like, would you rather trust a small IT security, like a setup, like a small team setup of high-skilled or medium-skilled or low-skilled individuals, or would you rather trust a huge corporation that you would think they have skilled people and they have security, they take it seriously? I think it's a tricky question because a small team of high-skilled individuals can make top-notch security. Like they can do the best. Can you just check if it's so a small team of high-skilled top performance individuals can make it very secure. On the other hand, the big corporation have all the resources to invest in security, but their attack surface is huge. They have like many instances, many setups, many entry points. So the question is, I would say it depends. It depends on the big corp. It depends on the small corp. I work with the good teams, and also I believe that actually when we hear about all these big leaks by like this, I think there was Travis was affected, and also like Code Climate, all these big even there was some reports. All these big corporations like Oracle, obviously, sometimes also there were some issues there. They so you hear all these topics, and sometimes there are very basic things. So you ask yourself, what were you doing there? So as I said, a small company can have high security, but have to, and also big corporation can have like a small high security. So most likely you have a CI/CD already. So you think, okay, how I can get several tools together.
Sorry to interrupt again. Sorry, we're having technical issues in the stream. Can we do like 2 minutes break?
Yeah, sure, of course.
Sorry for that. 2 minutes and we'll just have to test something. Can you switch off? Oh no?
Switch off what?
No.
Okay, sure. No worries. Okay, it's okay.
That was an interesting question. You'd rather but less code is more in terms of security, always.
Yes, that's the goal, definitely.
Yeah, so I can't trust big companies. My principle.
Yeah, that's actually, complexity is also like
that is not a friend of security. So I tend to remove everything which is not mine.
Okay, that's very hard.
That's my best advice, I think.
As a side note, I actually came back from a black hat. Now I was in
I've read these black. I've seen these.
I was also presenting about but there you should have like a laptop with nothing inside, and you know, because like you know, there's so many. I always bring like a dummy laptop and also like device. This is totally patched. Google 7 Pixel Pro, all the patches. Otherwise, you can come back with something.
Do you follow the security advisories, the CVS list? Have you looked at Exchange, for example?
Yeah.
This is Ubuntu, this is not Microsoft.
Yeah, I think so.
Okay.
So Ubuntu Linux now compatible to Microsoft.
I don't care. testing. No. I mean, I can try Chromium because I had some issues also in the past.
Back to StreamYard and see. Okay.
Okay, perfect.
Yeah.
Okay, perfect.
Okay, great.
So just talk to the laptop. Laptop is enough. Okay.
Yeah.
Okay,
So
just.
we don't need any of the additional wireless speakers and like the wireless mics and everything right now, right? Okay, that's fine. That's not an issue. So Martin, what you can do is like just to be on the safe side, switch off the thing.
It's already off.
Oh, that's brilliant.
Okay.
Great. Only because then we don't have an issue for feedback. And I think we're
Oh, okay.
yeah, we person can share his screen.
Oh, sorry. Presents, right?
Yeah, yes. Slides.
I think you share screen, and now share screen, and now this one.
Yes, perfect. Yeah, he
Okay.
is sharing his screen. Yeah.
All good now.
Good?
Okay, perfect.
Thank you so much.
Yeah, no worries. Okay, happy that we resolved some technical issues. As we know, we are like here around 20 people from IT, but we still struggle with. This is, I mean, no fun intended. This happens. I know. It's like it's typical. It's like I think it's called like in German. There's a word for this that whenever you need something, it doesn't work. So yeah, we need this microphone, but now it works. Okay, so as you can imagine, all the companies now have a CI/CD, continuous integration, continuous delivery. They pretty much have some tools they use for linting, for infrastructure as code linting, like a cloud linting or code linting, or even like code analysis using SonarQube or Sneak. I think it's called. One pronounce it Sneak. It's yes. So the people use tools. And also some open source tools. If you use Ruby, you use possibly Brakeman. If you use Python, you use a Bandit. If you use PHP, there are tools for this. also for JavaScript. So we have some tools, and some people will get creative. They write their own pipelines. So then you have a CI/CD pipeline, and you have like, I don't know, 8 tools. Each tool produces its own output or own report in different format for code. Then you have different formats for cloud. So you have like all these reports, and what you get now is like more stuff to read for developers. Like they, instead of making the life easier, it can make the life harder, because now they have like 8 reports to read, and I'm not sure they will like it. So the potential solution, I think, should be not to reinvent things, just tap into open source. I'm a big fan of open source. There's so much out there that it's amazing community, amazing solutions. It's also cost efficient, flexible, to cover both code and cloud and secrets and binaries. And you can also, you should be able to self-host it. Run it on your laptop also, if you want. So a server laptop cloud instance ideally with web interface, so it's useful. You don't have to, you can work on different platforms. Also, command line is also, in my opinion, a very important need. And the reports with standard formats like HTML, JSON, or Sarif. If you don't work with security, the Sarif is de facto the markup, the format for the reporting vulnerabilities, like reporting security reports. It shows like the line, the file affected line, the finding, and other parameters. And also, it should integrate in GitHub, in GitLab, Azure DevOps servers, anything that can read Sarif, which is standard, could be also great. And also possibly with as a GitHub action, because GitHub actions are free and very popular, or even GitHub app. GitHub app is a successor to GitHub OAuth apps. It means when you have a code on GitHub, you can very easily select a repo or organization. You can go to the app, say install this app. It gives the permission. You review the permission. Yeah, read code, make pull request, accept. Boom, you have an app in your GitHub. So it's very flexible. And also, ideally, you don't want to extend your supply chain risk. Connect to anything. Like don't use a solution that you have to connect to the that you have to allow them connect to you. So I call this plug out solution, that you can run it totally independently. Like you don't need to connect to any API, any scanning server. So we have many options. So that's the goal for the solution. And that's my pretty diagram to describe what I just told you about it. Like the concept is to use multiple scanners, like N scanners. Then there's a better scan platform solution that can be run locally on a laptop, on-prem server, instance, cloud, as a GitHub action or GitHub app. It maintains the scan state. So if you scan a big project, obviously we all work for big companies, so the projects are not small. My results, initial scan can last 2 hours with thousands of files. But then if developers work daily, per each commit, it will spend like seconds to minutes. So it's definitely very, very faster after this. It's important to the state, because you don't want to scan the project or the cloud setup each time. And then you have one report, and from this one report, you can export to JSON, HTML, Sarif, or also third-party interface. If you don't like the interface, you should be able to use you should be able to use your GitHub code scanning tab. The GitHub now has a code scanning tab. You can import there. GitLab also, or Azure DevOps server also. So what's the better scan value proposition? With one line, it's literally one line of code, one line of command. You can add several thousands of checks. I think now it's around 4,000 checks, and It's open source, flexible, scans code and cloud, secrets, binaries using Yara. I don't know if you heard about Yara. It's pretty much antivirus for open source antivirus. It's using binary and textual pattern matching, and they have a huge database of APTs, advanced persistent threats, crypto scams, like binaries that are malicious. They find the bytes string, and it's pretty much antivirus for open source. So it can scan binaries. Okay, you can hear me. Okay, no worries. You can run it yourself. You can modify it. I know you guys are great developers. There are possibly some open source contributors here. You can get the code, clone it, modify. If you don't like something, modify it. And also, there's full transparency and control. You can see in each line. There's no like some shady company code with a backdoor. We know this three-letter organizations that like to put backdoors and stuff. There's no backdoor, full transparency. You can also scale it. It's modular architecture, and it's written purely in Python for the core engine. The interface is then in React, JS, and also Python, but the core engine is in Python. So that's how it looks. That's a screenshot of the web interface. As you can see a project name. Then you can see the issues. There's also a log tab, settings. You can change the branch. You can click, if you click on the issue, it will show you the file, also the line where it is located. It's a very basic MVP-like interface, so don't expect much. We put a lot of value I put a lot of effort in an engine, because interface, people tend to use anyway the GitHub interface or DevOps Azure Server interface, but it's there. That's how it looks like in a CLI. To start the interface, the web interface, you have to run 3 commands to get all the Docker images, and you have it running. To scan the project with a CLI, 1 command in a project folder, boom, you wait some time, and it shows all the loaded plugins. In that term, we a little bit make the scanners of the whole products, like Brakeman, Bandit, Brakeman for Ruby, Bandit for Python. We a little bit degrade them to plugins. So in the terms of the system, each scanner is a plugin. So it looks here like a dozen of plugins, like Truffle Hog for secrets, Trojan Source is a custom plugin for Trojan Source. Then Bandit, Brakeman, PHP Analyzer, GoSec for Go, if you guys do Go. Then Confused for the confused vulnerability that you can trick NPM to get different projects, different repositories. Also PMD for Java, SemGrep, great project, is also there. SemGrep is a static analysis tool from US. It's great. It's called semantic grep. It's pretty much grep, but very smart grep. So it's all there for, as I said, also then Chekhov for Docker files. Docker files and infrastructure as a code. Also the Kubescape for Kubernetes clusters, other thing. So it loads all this, and then you get the report. The analyzer, description of the finding, file, line, and you have also things that is wrong. So then this is the HTML report, similar concept, finding, description. That's how it looks in GitHub interface. There's a code scanning, but there's a caveat, there's a trick to it. That in GitHub, to use code scanning, you have to buy it. Obviously, if you have that much money, you possibly, I don't know what you do, but yeah, it's very expensive. But for private repos, you need to buy the license. It's called Enterprise Security with Advanced Security. It means both keywords means a lot of money. But for public projects, you can use it. Freely. So you can definitely use the better scan for public projects to integrate them with code scan. They have also like a rules for Brakeman. That's the thing. With code scanning, you would have to make a scan for Brakeman separately, for Bandit separately, for code, for cloud. And here with one GitHub action or GitHub app, you have all those tools in one go. this is the GitHub app. It's actually it's live now on GitHub. To be on the marketplace, you need to have at least 100 installations, and then actually you can charge for the service. So now it's free, and you can if you want, you can try it. It's also available on the Backstage. I don't know if you guys heard about Spotify's Backstage. It's a developer portal that you can have like a tech radar, all this like developer stuff, and you can also add the Better Scan to it as a plugin. Pretty much it's from Spotify. They thought, hey, you want to make it easy that all the companies typically they craft some software and they build their own tools. Let's unify it so they make this better Backstage project that you can integrate with. It's a login sequence, login page, and then you can add many plugins. Also, Better Scan plugin. So benefits: it's secure. It's actually developed with security in mind. There should be no vulnerabilities. We have a security how it's called manifest, or we have a security procedure. If anything is found, this should be reported. So far, nothing was found, and it's a healthy code. All callable via REST API. You don't have to stick with the web interface. You can call it via REST API. You can make your own front end to it, however you like. Integrates with CI/CD. It's live and fast, and no need to connect to anything. Plug out solutions. You own your security. You are in control. So yeah, and it's also Java setup. No software, compatible with many languages like PHP, Java, Scala, Python, Perl, Ruby, .NET, full framework, C#, C, C++, Swift, Kotlin, Apex. Apex is a language for Salesforce. JavaScript, TypeScript, Go. Also, if you guys into decentralized finance, there's also Solidity scanning, and also DeFi security scanning for past exploits in a smart contracts. Actually, this feature was requested. I added it, but I would say the direction a little bit. It was an experiment, but I would say the Better Scan is a platform for code and cloud. And this DeFi was just was a request from one of the persons using it, but I would say the direction will be more cloud and code. And also infrastructure like Docker, Kubernetes, Terraform, GCP, Azure. Secret scanning currently supports 166 secret types. It's actually, I think, the most in the market. I actually spent some time to find all the registers for the secrets. There's a Git leaks, there's a Travelhog Git leaks, but they have all less. So this is like a master. I think it has the most secret types now. Supports the most secret types. Also, Yara rules for anti-debug, anti-VM, crypto, CVEs, exploit kits. I don't know if you guys know what exploit is. Exploit is a. If you don't know, exploit is a program that tries to exploit a vulnerability. So, like typically, a hacker would develop an exploit. It's a binary file or a script, and if you find it on your system, in your code base, or anywhere you scan it, it could be an indicative of a breach, of something nasty happening. So it's like a virus. So it scans this also. Malware, web shell. Web shell is it's a way that you can interact with a system via the web. Web shell, yeah, it's typically aftermath of the hack. If you got hacked and in your website Git repository, the Yara rules found a web shell, you were possibly hacked, but you possibly know about it before. So, but it's just good. That's good to scan for it, because you can show for a compliance and for a re-security that you care about it, that you check for those things. Also, other things, as I mentioned. So open source to use, as I said, I know I listed them here. It's ProcPilot for PHP, PMD for Java, Bandit for Python, Breakman for Ruby, Go, Confuse for this confuse dependency management, SamGrep for, they have support also other technologies, Travelhog for secrets, JSHint, and JSScan for JavaScript world. It also scans for Log4Shell. If you have some code bases, I heard it's amazing. I heard it's almost a year now. I see on Twitter reports from bug bounty hunters. They still find vulnerable
log for shell systems. It's amazing. I mean, it's such a big impact vulnerability 1 year after, and there's still companies that didn't patch. So with this tool, they would find it and they could hopefully patch it. So also check off for Docker images and cloud infrastructure, kubescape for Kubernetes, GR audit for Perl, InsiderSec for C# stuff, Flow Finder for C, FileSegBug for C, SLint for JavaScript, Yara, and some were modified so to fit the solution. So there are many features. Also, the web interface has like issue management. You can dismiss an issue, say, oh, it's false positive, dismiss it, won't come again in the scans. So it's very cool because you don't want to have to see the same report all the time. So you make it mark as false positive. Next time it doesn't appear there. You can enable, disable each check from each scanner. So we have this dozen of tools. We identify all the checks, and if you run these tools separately, you cannot do this. But with this system, let's say I want to disable this check from a scanner Bandit and this from the Brakeman. You can do this. So you can see also each checks that each tool does. It also has a snapshot for the state. So each scan is a new snapshot. Doesn't have to be scanned from the start. Also badges. You can see the badges on the right. It shows like how many red findings, high severity, how many medium, low, and informational. Also dashboards and reports format, different formats. What's the differentiation? Okay, so that's the point at the end, but it's very important that I think the human intellect and the edge cases are always the best in finding the deep bugs. As you know, Google has this Project Zero. They also run the OSS fuzz. It means they like test the software. And can you imagine that they have like almost budget without limits? They run this cluster platform for fuzzing, and still you can find bugs in Chrome, in Android, because the computer will never. I mean, I don't want to say never, because we all heard about GPT or how AI advanced. But what I mean is that the human is still the best, superior to all the tools. So this tool should be like any tools. I think any tools that are using for automation should aid in ensuring the baseline, ensuring the continuous security, and also proactively checking for things. But it's not like a golden solution or like a golden key or like how it's called, like a silver bullet. It's not a silver bullet. It should help you to maintain healthy systems, healthy code, automate whatever you can automate. And it can do this for cloud code. It's ideal for modern organization that using code, cloud native, also mobile app, because it will cover code, cloud, mobile app also, Swift, Kotlin. There are many possibilities. There are some users actually use. I mean, there are like 7,000 downloads until now, 400 stars. There are users in US using it for compliance, for checking the stuff. This technology is actually is based on previous project called Quantified Code. I happen to know the developer, and actually I took some code part from him and I improved it. So now it's called as Better Scan, but some components are reused from this open source Quantified Code. So yeah, as I said, the MVP is released in February 2022. Now it's like I don't know, 400 stars and 7,000 downloads, and the traction is going upward. Yeah, I mean that was pretty much it. So if there's any questions, thank you for your patience and for going through this with me. And if you have any questions about the code security, cloud security, or scanning, or this project, feel free to ask them now. Yes, please.
Yeah, how can a security tool differ between an intended remote access and a backdoor?
Well, the question was how can a security tool differentiate between remote backdoor access and intended access? Well, Well, this is more. I would say this is a little bit more different topic than this. But I would say using definitely some behavioral analytics, like if you have some past behavior of a user, did this happen always this way, and now it happens differently? You can kind of like guess, but this involves like machine learning, AI. So, but it's still very tricky, and that's why sometimes banks, if you switch from automatically, if you happen to be in Berlin, and then if you cash out in Berlin, and then a few minutes later you cash out in Singapore, they will flag you because the behavior is anomaly in the behavior. You cannot go from Berlin to Singapore in a few minutes. So if you think about access being the access to the ATM, you can find this a similar way. But I would say it's a little bit different topic than the code scanning. I was talking mostly about like you can find a backdoor, you can find a vulnerability that allows backdoor. But to me, what you ask is more like about security operations, SecOps, how to protect the organization from those kind of things. And I think behavioral analytics is big thing there. I hope that answers your questions. Good question.
So it's
Yeah, it's a big market. SOC, Secure Operations Center. There are now outsourced companies. You can actually share them also as a company. We got an offer that we can share one SOC team or a section with other companies, and they monitor the network and all this analytics 24/7. Any other questions? Yeah, sure, please.
We are using SonarCube for assuring code quality and also for fishing for secrets in the code. So is there an overlap of functions between Scan and SonarCube, for example?
Great question. So the question was that the question giver asked they use SonarCube, and they ask about also for code scanning and static code analysis, also secrets. And the question was, what's the difference between SonarCube and Scan? So actually, I know about SonarCube. It's one of the leading solution. They are already a while on the market. I think it's a very good solution. I would say the difference is that with SonarCube, it's really, you have to know Java. First of all, you need to know Java to understand it, and also to modify it to your needs. Because they also have I think it's called Community Edition also for SonarCube. So you need to know Java, very strong Java. Then you can extend it. But I'm not sure you can add all those plugins. As you know, the Scan has plugins written in Go, in PHP, in JavaScript. So I can plug pretty much any binary, any solution into Scan. And with SonarCube, I'm not sure it's possible. I think if you can extend it to only knowing the Java SonarCube API. That's one thing. Also, other thing was before, I think in the Community Edition, didn't have the state, as far as we go. But now recently they added state. So now also SonarCube, the Community Edition, also maintains the state. So it doesn't have to scan all the project all the time. Obviously, the interface is nice, clean. It's very professional solution from SonarCube. I would say if you're looking for a solution that you want to have more control, and it's like I call it a Swiss Army knife for code scanning. So it's a security automation platform, and SonarCube is more like a typically statistical analysis solution. So here you can make a check for example, a check for text for shell. I took me a lot of time to make this check. Boom, as a plugin, it's there. There's a new vulnerability, you can add it. With SonarCube, I think there are some limits. So that's, I hope it answers the question. If you have any other feedback on it, then you can feel free to ask me later. Or yeah. Any other questions? Feel free, please.
What's your personal opinion about Rust? Microsoft is heavily supporting.
So the question is, what was my opinion about Rust language? My personal answer, actually, I think it's a great language. Actually, I make some baby steps because I also developed some fuzzers, and there's a great project from actually also I happen to know the person. He now also works at Google. libafl. It's a fuzzer written in Rust. Very great project. And Rust, I think, memory safe languages will be the future, and definitely should be replace all this C madness and C++, because it doesn't. We have so many problems because of those. All these attacks on Android and on browsers are due to memory unsafety, and Rust eliminates this. Better code, better quality. So I'm a big fan of Rust. So. Okay. Then thank you very much.
So I guess Siri, right? You're next. Let's do like 5 minutes to set up the Test, 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 test.
Test, test, test. Can you hear me?
Test, 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 test.
Vielleicht versuche ich. Hello, hello. Settings. Oh, wait. Wi-Fi.
You don't have Wi-Fi?
I'm connected to my hotspot, but it's there, so I'm gonna bring it.
Oh, okay. Okay. It's green, right? Ich möchte Sharing gestartet für den Stream.
Ich möchte gerne überprüfen, ob ich Internet habe.
Yeah, I think you stop sharing for a second.
Martina, also ich möchte gerne jetzt die Presenter view.
Ja, einfach, aber hast du Wi-Fi schon geswitcht? Okay. Aber dann ja nochmal das Sharing starten müssen. Wo war das?
Warte, ich glaube, es war hier. Naja.
Also alles, was presentation mode, but I would do it like that.
And then for sharing
Then, yeah, for sharing, so when you're basically done with sharing the slides, I would duplicate, but for now I would extend.
Yeah.
Okay. Do you know how to switch No, so it's just Windows K, and then this dialog comes up. Sorry, Windows P. Sorry, Windows P, and then you can switch between the modes. So you just basically go back to, let's try if that works. Yeah, I think not. And then, like I said, when you Windows P, and then you can go to duplicate when you do the coding demos. Okay. Yeah. All right.
I mean, don't be bothered by it, but I'm guessing it's nice. Don't be bothered by it. I'm guessing it's nice. It's
I think we can start. Yeah. So I hope that my voice is going to be.
When you say something, just say something or something in front of you. Any read for, just read everything here.
Okay.
Just read. It is. It's all happening live. But it is break time, and everyone understands that. So don't worry about that. I'm just basically trying to see if you read everything and we listen. How is it sounding? Because the idea would be to make sure that we're capturing your
Okay.
when everyone is quiet.
Yeah. Okay. So I'm going to try now. Okay. For anyone watching here, we're just going to do some sound tests, so don't be bothered. Okay. Yeah, Reactor Berlin. First, connect to the Wi-Fi, adjust screen settings, connect to the StreamYard, and then share your screen. Test, test, test. Is my voice clear? Do you hear me?
I think this was the main concern. Like, is it working as you need? B, is it capturing your voice correctly?
Yeah.
Because I think the
It's
stream.
capturing my voice, but I don't know if the people are gonna hear me.
I think here it's still okay. Just you don't really have to throw your voice out too much. But as you see, like at some point, like when people are quiet, there are some optimal cases like here, maybe here, something like And then with you. And you can be faced, craned maybe at a certain angle or something like that. And if you speak straight, it's like, I'm just saying, like, based on like my decibel understanding and audio understanding, it works perfectly fine. People hear you. Yeah, it's just for the stream we were having a little issues with the some issues with the mics and stuff, but that's why we're like trying to do it mic. Yeah, you sound great. So. Thanks.
All right, I think you have to start, otherwise they will keep on talking.
Yeah. Okay. Yeah. Hi, everyone. Hello. Yeah. Okay, so let's start the third session for today. My name is Serene Shelley. I'm a cloud solution architect at Microsoft, and I'm not going to be doing some sales pitch or something. We're going to be talking about some technical stuff. And yeah, by the way, I see a very diverse crowd. So there are a couple of women, men, some professionals, some young professionals maybe, or students. Cool. But I think at least there is something that we all share in common. And that is our love for containers. I think we all love containers. Yeah, exactly.
That's what we all want.
Yeah, and there are actually multiple reasons for that, because they are small, they are portable, they run anywhere. That kind of makes them popular. Our lives, I think, got less complicated or less painful since we started using containers, as we don't have to think about installing the operating system, the dependencies. We just kind of build the container once, and then we can run it with just one command anywhere, be it on the cloud or on premise, literally anywhere with just one command. But wait, that is just easy when you have one container only. But the thing is, most of the time, you want to run an application that is spanning multiple containers. And I'm not going to start talking about the benefits of microservices here. And when you think about running an application that spans multiple containers, you have to think about managing them, scaling them, maintaining them, and all that stuff. And that's where you need an orchestrator. And way back then, there was a container wars going on where multiple competitors kind of were fighting against each other about what is the best orchestrator over there. But I think we all know who the winner was, and that was Kubernetes, which has gained the most popularity since then. And yeah, I think you all heard, if not experienced, how painful it can be to manage Kubernetes clusters. Yeah, and running managed Kubernetes on the cloud, for example, using AKS can make it a bit easier, but you still need to have the knowledge to work with it. And that is especially when you work or run in production. Yeah, and especially that you would have to be responsible for setting it up, for maintaining it, upgrading it. And believe me, that can be quite cumbersome. But what if I told you that you can run serverless Kubernetes? And that is suspense. Somehow. Yeah. Okay, the live conditions. Now I'm clicking on the next button and it's not working. Okay, now it's there. Okay, yeah. That is Azure Container Apps. That is the serverless Kubernetes. And with Azure Container Apps, we brought the power and flexibility of the full-blown AKS cluster to the serverless world. And as it is built on top of Kubernetes, which got kind of abstracted for you, it also gives access to the very well-supported open source technologies around the Kubernetes ecosystem, like Dapper for distributed application runtime, Kida for Kubernetes event-driven applications, and Envoy for the ingress stuff. And they are provided for you by default, so you don't have to install them or add some add-ons like on Kubernetes, for example. And our goal with that was really to help you focus on developing the code and the feature and working on the application and really letting all the infrastructure management stuff on us. Yeah. Now let's talk about what are the different use cases of using Azure Container Apps, or where Azure Container Apps could be the solution for your use case. And here's an outlook of what we can build with Azure Container Apps. We can run microservices with or without Dapper. We can deploy API endpoints. We can handle event-driven processing or host background processing applications. And with each of those applications, you can dynamically scale based on, for example, HTTP traffic or event-driven processing or CPU or memory or any scaler based on Kida. Cool, right? Yeah, now we have apparently to wait for the next slide again.
Teams ausmachen.
Okay.
Teams.
Glaubst du? Ja. Das hat aber die Martina gemacht, glaube ich. Okay. Yeah. Okay, now before we do some hands-on stuff, let's take a look at some of the most important concepts around Azure Container Apps so that we kind of all are on the same page. Yeah, okay. The first concept here is environments, because Azure Container Apps are deployed within a container apps environment. And that container apps environment is or acts as a secure boundary around groups of container apps. And container apps that are within the same container apps environment are deployed to the same virtual network, and they also write logs to the same log analytics workspace. So let's say, for example, you have a web shop application. Then you would have a front end and a back end, each of them in one container. And since they need to communicate heavily with each other, then they would be deployed within the same container environment. Let's say, for example, there is some supply chain management service. That one could be deployed in a different environment. Okay, the next thing is containers. We already talked a little bit about that, but let's talk about it in the context of Azure Container Apps. Well, the containers here, I mean, within Azure Container Apps, can use any runtime. They can use any programming language and any technology stack that you choose. And Azure Container Apps supports any Linux-based container image, containers from any public or private registry. And the nice thing is that if a container crashes, then it is restarted for you. You don't have to bother about that. And with that, we move to the next concept, which is revisions. And revisions in this context is an immutable snapshot of a container app. And you have two modes, so the single revision mode and the multiple revision modes. And the first revision is automatically created for you when you deploy your container app. And then if you enabled the multiple revision mode, then whenever there is a change in the configuration of the template configuration of the container, for example, let's say you changed the image or something like that, then there would be a new revision that is automatically created for you. And for example, in the example that I was talking about, let's say a web shop, imagine you want to have a version 2.0 of your front end that looks nicer, that has better features and so on. Then you would like to deploy it. You would have a second revision for that one, for the 2.0, and you would deploy it to your environment. And what you can do is that you can split the traffic between the two revisions. Let's say, for example, 2080, and then you would test that new version with your users. And once everything is working fine, they like it and so on, you can upgrade to 100% to the new version. And that is done using the ingress. Yeah. And the ingress in this context, so Azure Container Apps kind of allows you to expose your container app to the public world or to the public web by enabling the ingress. So you can use external or internal ingress depending on whether you want your container to be exposed to the public web or you want it to be just exposed from within the environment of your application. And the nice thing is that when you enable ingress, you don't have to create an Azure load balancer or public IP address or any Azure resource to enable your HTTPS incoming requests. Yeah, so before we go to our demo, I'm gonna tell you what we are going to do. And I'm gonna show you the diagram of what we are going to deploy. So we have a tasks manager app that is composed of a front end and a back end. And the images are gonna be pulled from Azure Container Registry. The state is gonna be stored in Cosmos DB, and the logs are going to be written to a log analytics workspace. And so the code for the applications, you can find it in the, I hope it is visible for the people watching online, but here's the link for the GitHub repository of one of my colleagues actually, and there he also has some tutorial series about Azure Container Apps that I personally like so much. Okay, and then I think we can go to our demo. Ja. Also nicht duplizieren, sondern das ist.
Doch, eigentlich dupliziert, dann kannst du es auf beiden Screens sehen.
Ja, genau.
Ja, das ist einfach, du siehst da, was du dort siehst.
Ja, genau. Okay. Okay, so what we see here is actually the Azure portal, which is the front end of Azure, actually. And yeah, here we see the resource group that I just created for this demo. And in this resource group, I already created the needed stuff except the container apps, so that we don't lose a lot of time. So you see here we have the container registry. I already pushed the container images that we are going to use for both the backend and the front end. We have our Cosmos DB, the log analytics workspace, application insights, and I also created the container apps environment. So because it takes a little bit of time, but I'm going to show you exactly what I did to create that. Okay. And yeah, in the portal, you can click somewhere here in general, because that is a bit big for now for the screen. But here you would find a button that you click and you get the Cloud Shell where you can run your CLI commands. And here I'm going to put my environment variables. And yeah, so you see here, this is what I used to create my Cosmos DB. We're not, it's not the topic today, so I'm not gonna focus on that. Here, the container apps environment. And we only need to specify, as you see, the name, the resource group in which the environment is gonna be created, the Dapper instrumentation key so that we kind of get the logs from our containers, the log workspace ID and key to store it in the log analytics workspace, and then the location where we're gonna deploy our service, which is in our case West Europe. And yeah, this is basically the command that I did run. Okay, and then I'm gonna proceed and create the container app for the backend. So I choose the name, the resource group, which should be the same resource group, the environment, which is the environment that I just created, and then the image. I specify which image I should deploy to that container app. Where is that image stored? So the registry server, here it's my Azure container registry. Then which port I am going to expose, port 80 in this case, and then the ingress, so that we just talked about. In this case, it is the backend. I'm going to set it to internal because I only need it to be exposed from within my container apps environment. I don't want it to be exposed externally to the public web. And then I specify the minimum number of replicas and the maximum number, for the sake of this demo, just from 1 to 2, and then the CPU and the memory. And here I added like querying the fully qualified domain name so that I just show you something, a small detail. Okay, I'm going to run it. Okay. Yeah. So you see here that we have, where is it? It does not appear yet. I have to make it even bigger. Yeah. Oh.
Can you quickly go to StreamYard?
Hide. Okay.
Stream? Can you quickly go to StreamYard?
Mm-hmm.
I think we're not presenting. And yeah. Okay. Interesting. Okay. Let's do it. I think we have to do it again.
Okay, no worries. Yeah, okay. So you see here we have the fully qualified domain name that is appearing because we retrieved it, and it clearly states here .internal. And if we had the ingress set to external, then it would be exactly the same thing, just without the .internal thing here. Okay, so back to our comments. Now we do the same thing, but for the front end. So it's going to be exactly the same thing, of course, a different name, a different image from the same container registry, and the ingress is going to be external because we want it to be accessible from the public web. Otherwise, what for? Okay. So now I'm going to go back to my Cloud Shell and paste my command. Okay, so you see here it's similar, but you don't have the internal name or the internal word in your domain name. Okay, now the next thing that I would need to do is to activate Dapper on my container apps. So let me refresh so that we see our front end and back end. And yeah. Yes. Sorry, I'm not very used to that view because it is because of the resolution. Okay, so it was disabled, and I put it to enabled. Now we're gonna enter the app ID, and the backend. So this is the backend. The port is 80. The protocol should be HTTP, and that should be it. And you see here that we have a component which is for our Cosmos DB. But I forgot to show you how I added that, but I'm gonna show you right away. Continue. Okay. So let me show you how I did that. And that is actually using this command, which is it enables the Dapper component, or it sets the Dapper component in our environment. It specifies which environment it is, which resource group, what is the name of that component, and then we just have to link the YAML file for the configuration. And if you wonder what that YAML file contains, this is what it is. Okay. Perfect. Now back to, this is all set. We're going to do the same thing for our front end. You're going to go to Dapper. We're going to enable it. The application ID. HTTP, and that's it. And you see here no component to display, because actually in the configuration file of the state store component, we specified the scope, and that kind of says, okay, which Dapper component can, or which Dapper sidecar can access or communicate with my component. And we specified the backend one. That's why we don't have any component in the view of the front end Dapper. Let's just save. Okay. Now let's go back to our front end. So you see here we have our application up and running. And if I say, yeah. I load my tasks. Yeah, I can see that I don't have any tasks now. I can create a new one. Let's say, yeah, fix bug or whatever, because always we have to fix bugs. I'm happy that I didn't have anyone know. Okay. And then today is, yeah, the 15th. And now we can see, we can have a list of them, and they are stored to our Cosmos DB, actually. Now I can just delete that. Okay, now if we are back to our containers, our container apps, we can see the different revisions. Now we have, in this case, we have only one revision, but imagine we just improved something, we added a different revision, then we would have another one here, and we can split the traffic. But by default, since we, for this demo, by default, it is the single revision mode. It is 200%, of course, by default. Okay, so that is for the revisions. Then containers, you can see, okay, what are the properties of my container? Then you can check the scale. You can add some scale rules, for example. And then you have the monitoring part. So we can see the log stream. And here you just see what is going on in your container. And then there is the console where you can run commands from within one. So you can choose startup command and so on. Can be helpful, especially if you're debugging some stuff. Yeah. So I think that's it. We can check some. Wait, I can show you the application insights. So let's go back to the. Yeah, here it is. Yeah, so we can see here the server response time. We don't have any failed request. You can see the different requests here. And another nice thing that I like is the application map, which kind of shows you how is your application, or are your application components interacting with each other, calling each other, how many calls, the speed, and so on and so forth. Yeah. Okay, so that's it for this session. Do you have any questions? Yeah.
I have a question. The concept of containers is universal, so I can run it everywhere.
Yeah.
But if I use, for example, application insights,
Uh-huh.
I cannot. It's only it can only run on Azure, I think. So what's the use of using application insights container?
It is not an application insights container. Actually, application insights is an Azure service for monitoring your application, and you can use the application insights SDK from within your code so that you log what is happening to application insights. Yes, if you're using application insights within Azure.
Yeah. So, but it was called container application inside out.
No. It is not. It is actually just the service that I used. Yeah. It is not a container. Yeah.
Oh, okay.
Yeah.
And maybe one addition, the instrumentation, because the map came from Dapper, and Dapper speaks open telemetry, so it's open.
Yeah. Thank you.
Can you tell a bit more what is this Dapper thing? Like what is actually that? This is Dapper. Yeah.
Yeah, so it is open source technology that you can use. For example, here it is very useful for the service discovery because you don't have access to the Kubernetes API. So you use Dapper, for example, to know, yeah, where are your containers, how to access them, and so on. It can also be used for, as a state store. Like we use it for also for Cosmos DB and so on.
We're definitely going to have a Dapper session in one of our next reactors, so stay tuned.
Cool.
Yeah.
Yeah, sorry, because with the lights, it's a bit difficult to see the raised hands. Yeah.
Is it possible to run the shell inside the container?
Yes, that's the console that I was showing. So, yeah. Ah, okay. Yes. So somebody was asking if we can run the shell from within a container, and actually, this is done from here. Wait a sec. Console. Yeah. Yeah, exactly.
Thank you.
You're welcome. Any other question? Mm-hmm.
Yes. Typically, Microsoft tends to be a one-way street. Can I port Microsoft containers back to Linux containers, for example? Is that possible?
What do you mean Microsoft containers to Linux containers? Because
big enterprises tend to attract technology.
Mm-hmm.
And is there a way back to free software, completely free software? Means whatever I use or construct in Microsoft environment, can I backport that to, for example, Linux environment?
yeah, so actually with Azure Container Apps, you can use any Linux container image, and then the image, of course, you can port it anywhere. So you're just using the service to run to create a container running that image, but that image you can also run it anywhere else.
Ah.
Yeah, and also the container registry. So even if you host that image in Azure Container Registry, you can use it somewhere else. I think so. Maybe I should verify that. Yeah.
Well,
Yeah.
we will see.
Yeah.
It'll be very interesting to see.
Yeah. But of course, the image. I mean, you can run it anywhere.
I also have a question.
Mhm.
So the question is, I'm familiar to some extent with Amazon services, Amazon Web Services. I'm wondering if I have this shop with front and back end, it's online, and then there's supposed to be some distributed denial of service attack. I'm wondering, was hacker attack? I'm wondering what products in Microsoft Azure, what products are there to protect me against this kind of like first distributed denial of service? Will it handle it? This huge load, cluster. And second question is if there is any product that can like protect me from like a WAF, like a RASP or WAF, that can protect the application against those malicious attacks.
Yeah, actually, you can put your environment in a network security group. You can put some security rules there with a web application firewall. Of course, yeah, we have that. Yeah.
And I'm wondering because Amazon is not so clear. I know they have some protection for DDoS. Like I work for companies and I know we have this. But I'm wondering what is the policy of Microsoft or Azure? Let's say if I deploy the app in my shop, and suddenly there will be a huge botnet that the what you can hear about those attacks coming from different parts of the world. Is it terms of service? Is it included in terms of service or?
Yeah, I think so.
Okay.
Yeah, I'm not a security specialist, but I think so. Yeah.
Okay, so it should be always up. It should be always up.
Yeah, of course you can protect yourself against DDoS attacks using Azure for sure. Yeah.
Okay.
May I jump in there? So first of all, to reach to your Azure Container App, you have to set up an ingress controller. Without that, these will never be reached from outside. That's the best protection you can have. Second, when you use Docker within your Azure Container Apps, you'll be protected extra because service-to-service communication happens then through Docker, which is mutable TLS using for the connection, and then you're as much safe as you can be in those cases. Okay, so these are the two facts you have to know. Till yet, you cannot place AKA into a secure environment in the meaning of having your own virtual network or something like that. That's still not happening. It's on the roadmap. I hope it comes soon. So, but the very, very important point is it's not reachable if you don't want it.
Understood. I mean, the reason I ask because I know I've seen the console of a cluster or like of the cloud stuff, but it is a huge traffic. We talk about like the huge attack, like the company will be under pressure, like Microsoft or Amazon.
Yeah.
And will those egress handle it? I assume yes.
For sure, you can put in APIM or Azure API management in front of it so that you are protected with that or the application file or something like that. So you just need to look it up. But to be for the first instance, you're safe due to the fact that you do not have any risk.
May I ask you about this three?
Sorry, just before the question.
Yeah.
Just before the question, I don't want to backtrack. Just what you took the thing of the, I guess what you configured the ingress controller with the ingress, then deploy and modify the ingress controller. And regarding the MTLS thing, it's kind of set of safe service mesh. Most of the service mesh are using sidecar, and MTLS doesn't encrypt communication between containers. You still have to go to the kernel and back to the sidecar. So MTLS is kind of safe, but if you have access to the nodes, then they can still read everything happening on the cluster. So it doesn't like entirely answer the question, but kind of. But still keep in mind that everything you deploy is behind Azure load balancer, their own load balancer, their own hardware, and this is safe. So I won't trust what you're going to do on top of Azure. You're going to do a lot of mistakes, I guess. But you can trust the own Azure hardware and the type of security they put in front of your own software. This is very safe. And DDoS has to go through their own hardware before reaching your application. So they will say for you.
That's because I'm wondering, like, if you're like a big customer, like I think it happened. There was this attack on, I mean, on the U.S. White House. There was a big attack. If your customer is White House, and they slam your network, the hackers, through your infrastructure, this will affect other customers.
Sure.
So I'm wondering, if it comes in terms of service, I think it's fine.
Yeah, absolutely. So what you see here are the services that we kind of deployed, but that does not mean that that is all what is in there. Actually, there are some things that kind of abstracted for you, so they are there, but you don't see them.
Understood, yeah, of course.
Yeah.
Thank you.
You're welcome.
All right, guys, let's wrap it up because the pizza is getting cold. Let's continue the discussion while eating, and we'll be back for the stream in about 15 minutes. So let's say like 7:05.
Thank you. Thank you for your attention.
Hello, hello. Testing, testing. 1, 2, 3. Share your screen. In StreamYard, use the share screen option at the bottom and extend your screen while sharing. This is a test. This is a test. This is a test at the Microsoft Developer Community Azure Meetup. This is a test. This is a test. This is a test. Testing, testing. 1, 2, 3.
it's a little bit unfair because when I'm staying there, I cannot see anything here. And when I'm getting there, they can see me here, but I can't see anything there. So, good evening, everybody. I hope you're no longer hungry, but still awake and still have the power to listen to my talk now. Of course, thanks a lot. That's nice. Responding to me is very nice. So if there are any questions anytime, please don't hesitate. Raise your arm, raise your voice, and talk to me, even for the remote audience, please. Okay, so my talk today is, my name is Ralph. I'm talking about Azure Static Web Apps with a real-world use case. So that was a special wish by Microsoft Reactor, especially Martina and Thorsten asked for that. So I'm going to show and share a little bit of my experience with Azure Static Web Apps. What we're going to see is what are Azure Static Web Apps in general. So features, what they do, what they not, requirements, pricing, and all the important stuff, and quotas for sure. Then we go into something to me new, which is the Azure service for the static web apps. And then we dig into the real world sample, which is a running web application. Is that fine for you? Okay. A little bit about me. My name is Ralph Richter. I'm working as a lead dev and cloud solution architect at the company called /Net Business GmbH. They have three entities, one at Friedrichshafen at Lake of Constance, one in Munich, where I'm working, and one in Stuttgart. We are right now 260 people in that community. And yeah, that's all about. We do software. Okay, static web apps in general. Is anybody here around already using static web apps? Yeah, 9? Okay, cool. So you were asking for free services, and static web apps has free tier, right? So that's why you use it. In general, Azure Static Web Apps, when they came up, the picture didn't change yet. That was the rough architecture picture of the Azure Static Web Apps. It's by itself, when you hear the name Static Web App, it is providing a service where you can host static content, and you can enrich that content to be a little bit more dynamic by having an API in behind. So we call that BFF, and BFF means not best friends forever. That means backend for frontend. Okay. So, and when everything starts with some code, is that right? So you have to write some HTML, JavaScript, whatever you want to, and you will host that in a code repository. In our case, mostly it is GitHub or it is Azure DevOps. And to deploy your code from there, it is mostly recommended to use one of those first-tier suppliers to Azure Static Web Apps. That means they are highly integrated into Azure. Azure Portal already offers you the possibility to configure that, and then you deploy your code towards the static web app. And the static web app is nothing more like a bracket around, let's say, a storage, and an Azure function if it is built in, or something you can bring your own. So let's wrestle a little about the features. So we have in common web hosting. That's done. We have the API. You can use built-in or bring your own. We have the first-tier integration set already. We have support for other repositories as well, which is new. So by using a deployment token, you can use GitLab or Bitbucket, for instance, to also share your code there. A nice thing is that you get free SSL certificates, which is for a lot Microsoft Azure services in common effect. You have to or can use custom domains, which is, for me, very usable. And you have integrated alt functionality for different alt sources, like Microsoft, Facebook, Twitter, GitHub, and you name it. you can implement them. So you can have an authentication method within your web app using a built-in functionality which will connect to one of those OAuth providers, and then you can authorize your user. It has also integrated roles and rights management system, which is really cool. You can highly configure how the app will behave. And with highly configurable, I mean you can protect the API especially, you can protect URLs by wildcard, by specifying them, by adding roles who are allowed to navigate to it, and so on. So you can also have rewrite rules, all that stuff, which if you've used ever an Apache server or something like that, you will be very familiar with that functionality in there. Yeah. What? If you use Azure Front Door, yes. So Azure Front Door will automatically navigate your user to the next service where your static web app is made. One of the benefits is that static web apps is globally distributed through different Azure regions. And that means that static web apps are almost on the nearest spot to your user, which is very useful. Okay. One thing I like a lot is that you have a preview mode, and this preview mode got extended from the first version of static web app with you have now the possibility to say you have a named preview path, let's say. You have the possibility, which was built in from the first step too, on a pull request, and you can have a preview built upon your branch setting. And you can also password protect these preview builds, and you can easily set that up in the Azure portal. Let's have a look. Let's have a look later on how it looks like, because I have to switch the screens and then I have to stop the sharing. We will go through that later in the demo. Okay, so I've talked about BFF, and still not best friend forever. It is like you can have an API within your front end, which is pretty important, right? You have to have less business logic in your front end, in my opinion, to secure your content, to secure your data in general, and put all your business logic into an API. Agree? Just to be safe and just to have, let's say, a stupid, simple front end, just presenting data and not thinking about data or doing things with data you don't want to. So by ensuring that with an API, you can now have, beside Azure Functions, also Azure Web App as an API service behind. You can have Azure API management. And how cool is that? Azure Container Apps. I like it a lot. So Azure Container Apps is one of my most favorite services for the moment. So very quickly fast. With Dapper built in, you also have a possibility to separate the API and your, let's say, non-functional requirements, like having a state store, service-to-service communication, and all that stuff can be done with Dapper, and you don't have to implement it into your code. So this is really cool. Azure Container Apps are now built in, so maybe you didn't know that yet you have an answer for that. Okay, so Azure Static Web Apps is not made for every use case. It has strong limits, and this is what we will see here. So for the free plan, you have 100 GB per month per subscription, and also for the standard plan. But what is happening here, when you go over that, your service will be done. But with the standard plan, by 20 cents, you go for GB, yeah? So you have to think of how many traffic will your service consume. You have, with a free plan, maximum 10 apps, and the app size can maximum be 250 megabytes, and yeah, some other things. Which I found interesting is also the custom domains that you have just in the free plan 2 per app and 5 in the standard plan. Something more. Allowed IP ranges is for me a really, if you go into an enterprise context of the static web app, you have to have allowed IP ranges to manage or access your application on the web, and there you can have 25 allowed IP ranges for your web application. As I've said, there are built-in roles in the static web app, and we have authorization as well. And here we have a limit of 25 end users that may belong to a custom role. This is very limited. Yeah. Both. We're talking about IP ranges, right? Yeah. Usually you go that for IP4. Okay. Step back on force, that's force. So that was an interesting thing. And the request size is limited to 30 megabytes. It can be an issue if you want to upload a DVD or something like that. Yes. So back to the first slide of the code, I want to highlight as well that your plan size is, for the maximum size for your application is 500 megabytes, and in both cases. And 2 GB for all your stagings. So you can have 3 stagings, and in the maximum it can be 2 GB. How can that be? I don't know. It's like that. Good. Hosting plans? Yes. You have, let's go back. You have unlimited roles. It is here. You have unlimited number of roles, but maximum 25 end users may belong to. You can define roles as much as you want to, but it's a little bit tricky. You have to add a user if you want to give him a role. So you have to do that in the portal. You have to invite the user to that role. So that means you have maximum 25 users in your backend with the role. Yeah, with different roles. Yes, you cannot exclude. Yeah. Not with the built-in custom role section. You can have your custom authorization and role model in behind using Azure Active Directory, for instance, where you go over Active Directory rules. Then you can highly customize that for you and make it much more easy to manage it as well. Yeah, it's for sure that's possible. Yes. Yeah. No. So 100 GB per month. If you're going over that, you have a lot of users visiting your page, or your page is having a heavy load for each response. Yeah, they will shut down. No, if you use the free service, they will shut down the service.
Yeah, and you can always monitor your service within the Azure portal, and you can use application insights or log analytic workspace to also analyze your traffic. Okay, does that answer your question? Nice. Okay, so we have hosting plans, and hosting plans is in fact more or less the same like the plans before, but here it says some more other stuff like it states first of all what kind of these hosting plans are meant for private projects and more for production, and then you have here, I'm sorry, this is a German implementation. You have web hosting, GitHub integration, Azure DevOps. And you see it's almost the same. Beside the fact that we have staging here, and this is 3 Pro per app, and 10 on the other side for the standard plan, then the maximum size of the application differs, and you have also the difference between the custom domains. And then it starts to being interesting, because with a free plan, you just have Azure functions which are built in. And with a paid subscription or with a standard plan, you can bring your own functions, APIs, let's say, because it's no longer just functions. And also that you have the possibility of an integration for other authenticators. And this is the question of your 25 roles. So I'm a little bit, I have to disappoint you. Okay, he's not doing what I want. Don't give me. Oh, it's my fault. I shut down the service today. I had a huge problem with Office today with my computer. That wasn't nice. Really. M365. Okay, so as you can see here, we have this pre-configured authorization service, and this is the free plan. And here you can have custom authorization. And that's the one you wanted to know, right? Yeah. I'm sorry, you have to pay for it. But I guess when we come to the plans and the pricing, you will see by $9 per month per app, that's not really worth talking. So you can either go for what other hosting partners if you have the need to, or otherwise you just go for this cheap application and use it on the way you want to. And I don't have any more to add here at this page. So then there is this interesting thing, Edge for Enterprise. And who was asking for being near to the customer? That was you as well. So with Edge for Enterprise, you get something really interesting. So you have 180 plus edge locations where your application will be distributed to, using front door in front of, using CDN and behind, and better compression for your files to distribute the application to your users to be next to them, which is specially made for enterprise. So I find this very interesting because often it is a stressful thing to have less latency towards your user and have a good user experience with your application so that the consumer is not frustrated. In the automotive, for instance, it's a very important thing. Please. No. No. No, it is, that means that you are distributed to different regions over the globe, and on the edge means in more than one region of a country, for instance. You can have private link or private network to link to your application as well. So then it won't be longer available from the outside, and you have to link it with your private link to access it, or a virtual machine which is in your VNet. Okay? Okay, the real world use case. Yeah. The things. Azure, see, what means familiar? Which one? CDN of Azure and Azure CDN and CDN in general CDN. So yeah, there are many services doing that. So like Cloudflare or I don't know really. I have never done a I have never done that. I have never done a complete view on that. I'm sorry. They work for me, and I never had I had always the benefit of it, and did not had the stress to review that. Okay. Yeah. They're not offering that, they're using it underneath. Okay, so it's a little different difference in here. So remote folks, you couldn't follow. Here was a little discussion about what the CDN services in the outside of Azure are performing and are they comparable to each other or not. And I didn't have the chance to do that yet. And Martina was a little bit going deeper into it and explained a little bit about that. Okay. So real world use case. Lucky me, I'm running community services or community, and one of our goals for one of our communities is to bring a conference to the developers, filling the gap between IT Pro conferences and trainings. So we felt there's a gap about that. And this happened, what date is it? 2 days ago, at 13th of December, in Munich at headquarters of Microsoft. Thank you, Martina, again, for sponsoring that event. It was really cool being there. We had 4 tracks, 35 experts talking about Azure and stuff, and not only Azure, we have an open track, so it's also related to other stuff around development teams. And that was a real success. But how do you bring people to that event? How do you inform people about your event and all that stuff? So you have to have a website, right? And Martina asked me to bring a real world case for the static web app, and we, for sure, as an Azure community, use the static web apps. And our requirements were like, we want to have static content. That's a critical issue due to the fact that we also want to be sustainable. And we wanted to have a modern way to do our hosting, and we were focusing on performance as well. We tried to be responsive, which is nothing more than CSS. You know that better than me, for instance. And we wanted to have the registration on the page, which is also not belonging to static web apps. But that were the rough requirements of our web page. So what you see here on the picture is the result. So this picture is a picture of our live website. And what we have in our real world example is we use Azure and a lot of Azure services around. So we have the static web app. We have also Azure DNS zone to provide the custom domain, https://azuredev.org. We also have the app insights to monitor our application, and we are using Azure Maps to show a spot on the headquarters in Munich of Microsoft. As our code repository, we're using GitHub, and for deployment, we're using GitHub Actions, which is pretty cool. And we have decided to go by Go Hugo. I don't know if you know this project. It's written in Go, and it's using front matter underneath to set up and build static web apps or static web pages. The IDE we're using is Visual Studio Code, so we're still without the need of a license, and therefore you have to install to locally run your application. The Go Hugo server, you have to install the static web app CLI and the function core tools if you want to use an API locally. And only in the case you're using functions. Otherwise, you can use anything else. So what does the architecture look like? We have on the left our code repository and our actions. And on the right, we have Azure with a static web app. And in this case, we do not have any API underneath. There is a reason for it, I will explain later. We have Azure DNS Zone, Azure Key Vault, as I've said already, and App Insights. Does anybody have a question about what's a Key Vault, or do you know that? Okay, then I jump just over it. Key Vault is a secret store for certificates and secrets, a high secure store. Okay, so Martina told me I have to stop and rejoin the streaming, right? First deduplicate and then, okay. Okay. Oh, nice. Hey, hi. I know you. Yes. Yes. Yeah, I will show you in a moment. Okay. So what I've promised is that we will have a look on the static web app itself. The static web app itself is just a service you can deploy by using Bicep or anything else. Okay, watch. I've shared it. Soll ich nochmal rausgehen, oder? So, ja. Sorry. Okay. So there was a question, what's my favorite tool to roll out static web apps, right? In general, I'm using, so I do not have a huge need for static web app or static websites. I'm running 3 of them, and I'm using, so for deployment, I'm using GitHub Actions in all 3 cases. Yeah. And that's not only because GitHub Actions was the first year implementation of static web apps. I love GitHub a lot. And if you have a chance to go and drill into GitHub and GitHub Actions, please do so. Okay, so this is the code, how it looks like, so how our website is looking like. We still have an API here inside, and as you can see, we do use functions here, and we have also a function API inside, so if I want to, I can trigger that from outside, because that's deployed as well. The idea was to have this function. So when you run a conference, you want to involve speakers in your conference, right? So there is a problem on how do you get all the speaker details and the idea about their title and track and how can you organize and structure that and how can you, I mean, spread the word out in the world and share that and get it done in the time. And how do you then do selection and all that stuff? We were using Sessionize for that. Is Sessionize a name for you? Do you know that? No? Okay, that's a special tool for conference organizers to have a call for papers or call for speaker, and you describe your event there, and you describe what you want for type of speeches, how long they have to be, what services do you offer to them when they come to speak, and from when to when the CFP is open, and as well from when the event is planned. Okay, that's literally what they see, and then they go share their name, a title, a description, a photo, and all that stuff, so that we can make a selection of these speakers. Okay, pretty easy. That means also you have to get the data out there, and you don't want to do that by hand. So we developed a small tool, which is not the API. That was the first guess that we will have an API. So what we did is we developed, where is it sitting? Have to look in. So we have decided to go by a command line tool, and we named it Sessionize to Hugo, and that's nothing more than a command line tool which will run in a GitHub action. And what it does is it requests the Sessionize API, collects the data, and then pushes the data into the repository, and then it will be published on the website after the build process is done. Okay, got that? So pretty flexible and powerful stuff you can do with small things, combining a little bit brain power and the flexibility of tools. So this is really cool with static web apps, because just on request, for sure, right? So you usually, once the CFP is done, you don't have to build your site newly, except for the point that you have changed the schedule, for instance. And I can promise, in the past 14 days, we had a few changes. We had to build the page somehow often. But yes, now it's done, the event is over, and the next build will come or happen when we will add a little page about wrapping up the event. Okay? Yeah, please. No, we do not need to do so. We know that we have plus 100 pages due to the fact that we have the sessions, and on the other hand, we have the speaker details page. And the fine thing is with Hugo, you get the possibility to get the data out of, let's say, YAML or JSON file, and then build out of a template, a speaker profile. Okay. I'm talking about the website, and you can't see anything of this website. Let's go onto the website and have a look onto it. Are you fine with that? So here we go. I'm connected with my mobile on the LTE, so it's really fast. And we go onto the US style. So multi-language is also implemented, and it's also a functionality by Go Hugo. And I mean, it doesn't matter if you go Vue.js, if you go for Angular, or whatever you want to do. You just host it on static web app. That's what static web app is made for. YAML files, and so the template can be in YAML files and JSON, and yeah, that's it. Okay, so here you have the speaker page, and so you can see we have those plus 30 speaker here, and each of these have its own details page and a reference to their talk, so that you have an idea about what he's talking about and so on. And on the other way back, you go on program and you have the reference from, let's say here, Cloud Native vNext, which was given by Thorsten Hans. Here we have a live stream link, which is the link on the YouTube, on the Teams channel. And here you have the description of him, and here's the description of the talk. So this is literally what we was setting up, and you cannot imagine how many stress that can give you. If you have to import data from outsourced party. And if you want to hook up dynamic links into everything, and also CSS is not a fun, but we managed to do so. And I'm really happy that I can share this with you. This template of our conference website will be open source in future, including the Sessionize to Go Yugo template or generator, so that you can use our developed website as well. And future, if you're going to organize your own conferences, maybe we have side there. Yes.
Content is something feeling,
I can show you.
dynamically generated with all the text including.
So the thing is, the dynamic happens during the build process, right? Not in the browser. There is a static file called by requesting the web page. And you don't do any dynamic inside. The only dynamic we have in our webs is, or the only JavaScript is this register page. Because that's going to Eventbrite, which we've used to embed the registration for customers, for users. Okay? So that's the only thing which is not static. It's JavaScript. Okay, doing a call to Eventbrite. So we have here our partners YAML, as you can see, and this is how we set it up. The data is here, and this is portion of Yugo, taking the partner out here and putting that into the theme. So we have here our theme, and we have the layouts, and within the layouts we have, let's say, the partials. And within the partials, you can see then, okay, I can navigate better here. And we have the header and so on. So you can split your page like you do in Vue.js or Angular or React as well. And here we have our sponsor page, and there is the single page. And this is what it looks like when you grab the data from the data within your project. It calls the things out and put it together. And this is done in the build process. But this data here is grabbed from Sessionize. So stickers, for instance, is given by Sessionize. So this is demo data, not the current code on our deployed version. Okay, cool. Any questions? If not, I will drag into our. Yes, please. Sorry? If you find a service doing that, or a package which is doing that, or JavaScript or whatever, I don't know. Haven't thought about that yet. You can do that. I'm not sure which framework is available to do so. No, maybe no. So how does a typical? So this is not a typical GitHub action, but how looks the GitHub action for our side? As you can see, you have to define who's not familiar with GitHub action. Okay, so. First of all, what else pipelines are you using then? Jenkins? No nodding. Okay, what no pipelines then? Okay. Bash, okay. Bash is not a pipeline. So for Azure pipelines, nice. It's also cool. So you have here the thing that where you configure on what you're listening, what is the trigger, and I haven't synchronized, because what you will see here is you will not be able to manually trigger this action now. And then we define the job, what's to do. And here you can see only if it is a push, a pull request, or a closed pull request, then you have to deploy, and so on and so forth. And with this section here, with that submodule, we call our sessionize to Hugo CMD, which is a .NET version 3 setup thing, and then we go release that stuff, build the DXE, run it, and then we put our export to sessionize to Hugo. So afterwards we go build and deploy, and this is how it's closing and pull request at the end of the day. So this is all, a few lines of code doing all the magic for our website, which is pretty cool for us. Great. So now I've been on my website, and you see, you asked me that question too. So how many requests are going here and which data is going out, so that the measurement is already there. You don't have to take care of that on other ways. And you can also monitor that for sure. We have the implementation of Azure App Insight here. We also have this custom domains, which I was talking about. When you originally deploy your static web app, you will get one of this nice lively hill or blue ocean or something like that named URLs. And from that point on, you go and add your custom domains to that. And what I've done was adding Azure DNS zone to host my azuredev.org domain, which is pretty much easier to have these custom domains here, because I just go and say here, add a custom domain using Azure DNS. And if I do so, I just select the DNS zone, and then it's done for me. Otherwise, if I do this, I have to register a TXT or something like that into my domain to show that I'm the master of this domain server. And that's being validated. I then have the possibility to set this domain to my default. As you can see here, I have set this domain to my default domain, so it's no longer the lively hill domain. Okay, so APIs show up here. If you have one in your code and you've built one successfully, it loads a little bit longer, but you can see it here. In production, we have a function app and we have a resource in there. So I do not have to say anything about environments. Environments are these preview things where you can have your pull request previews or named previews or your branch previews. We have none of them. We do not have any role management. That was also a question here. This is the point where you can invite someone to your application when you want to, and you have configured within your static web app config that you want to have authentication for maybe a specified path. Then you go here and invite that person. There is the possibility to have a system assigned or managed identity. We are not using it yet. So hosting plan, enterprise grade edge is the thing we talked earlier. And here are also the private endpoints, which I've mentioned earlier as well. So if you have a VNet for your company or for whatever project you're running, and you want to host a website inside that project, you can put static web app into these environment, private network, and then you can reach it there instead of being reachable from the outside. Okay, so this is the most important thing about Azure Static Web App itself. And now I want to show you a little bit more about what we've implemented as well. So this is a DNS zone, and that is a pretty easy thing. So you just have to add the DNS zone, set the name server for that domain towards this set up a domain zone, right? So Azure, after deploying the DNS zone, Azure will give you the name service you have to configure for that domain. And after you've done that successfully, you can easily set up your, so here are the domain name service, which are going to resolve the requests. And on this lower end, you've seen the configuration to the static web app, which is pretty cool. Look, so there's my Office 365 implementation as well. And here we have www.azuredev.org. And this is going to Lively Hill, which is my static web app, which we've seen before. And we have also the add domain, which is going also to that Lively Hill. So pretty easy. I have another static web app, which is a Blazor static web app. It's running a virtual scratch. I don't know, virtual Oberlose. I don't know how to say that in English better. That's also a tool I've used for my conference. So these are the things I can share you with and about Azure Static Web Apps. Do you have any questions? Yes, please. No, you don't. You have to build that by your own. You can do so by having an API in behind. I've done that for my other web page, which is greenmanifesto.de. It's a web page for a sustainable community, and when you register there, it has to be approved, and then it'll be shown on the website. So you can do that by an API. If you're a software developer, you can do anything. Okay. Are there any more questions? None so far, so I'm done, right? I hope you didn't slept away yet, and you enjoyed it a little bit. Thanks a lot for your attention, and I hope we can have and share a beer yet with each other. Jetzt ist es blau.
Yeah, so there's one more talk, so please remain seated. I will take you like a quick break. The next one is about Am besten in die Hosentasche stecken. Und das am besten so ein bisschen unter das Kinn. So, irgendwo hier, nicht, nee, nicht am besten einfach hier so. Weißt du,
Ach
hier
so.
Nicht zu weit oben ist.
Was ist das?
Ja, wir machen nochmal einen Aus.
Yeah, sure.
Mic is directional. That's why it's important where it points.
Hi. Hello. 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 How are you? Hi. How are you? Hi. Can you hear me? Mustafa.
Mustafa, nice to meet you.
Thank you.
Could you maybe say a few things, maybe read a few lines just from here or here? Just read it for like
Okay.
go on for a few seconds. I just want to catch your audience.
Okay. In StreamYard, use the share screen option at the bottom and extend your screen while sharing. If you use PowerPoint, use Presenter View in Tab Slideshow. Referenzsicht in Tab and Präsentation to see your notes. You hear all of them? What did I say? I hope that. Can you hear me?
I would just say, sorry, repeat that again.
So, good evening. Can you hear? The next part, late part. I hope you're still energized and fully motivated. Perfect. Good. So everyone is there. Can we start? Yeah? Cool. So good evening, everyone, and welcome to today's event, last part about infrastructure as code, one of my favorite topics, with Terraform in Azure Bicep, open source against Azure Native Framework, infrastructure as code framework. I hope you're still full energized and fully motivated. But I have a very good news for you. If you just participate, just look at with full attention in this part. But at the end of the event, I will give you a news from. So with that, so let's few words about me. My name is Mustafa Imal, and I'm Microsoft Customer Engineer and support Microsoft Enterprise customers regarding of high-level cloud-native architecture and cloud-native applications, but more specifically regarding of everything container services in Asia and infrastructure as code with Terraform Bicep and CI/CD pipeline. So with that, today I'm very happy to introduce you the two main or common use infrastructure code frameworks, Terraform, so the open source one, and the Bicep Azure Native framework. So what exactly you are going to see today? So I'm going to tell first of all a very quick review on what exactly infrastructure as code is, why you have to use them in cloud-native environments, and what benefits brings to us. And next, a little bit more deep dive and two common use infrastructure as code frameworks in Terraform and Bicep with very special demos and all concept around of that. And last but not least, we are going to finish this part of the event with a comparison between Terraform and Bicep. So what is the difference? In which case it makes sense to use which framework in cloud-native environments. So As all of you already know, with the usage of cloud computing, but more specifically in the environment that we are all busy, cloud native architecture and cloud native applications. It's an environment, it's raising all the time. So almost every company is now in the cloud. Most of the companies are developing their software in the cloud. So it means the concept of cloud native architecture. So in the context of infrastructure as code, I found the definition of cloud native architecture from Cloud Native Computing Foundation, and I found a very helpful, a very specific part of that is, as you can see, it's just marked a yellow color, the immutable infrastructure integrity APIs. What specifically this means? It means in the cloud native environment, in cloud native applications, one of the important parts and pillars of that is infrastructure code with the declarative APIs. Of course, it doesn't mean only infrastructure as code with declarative APIs. It means the same way as well as when you're just defining your Kubernetes desired state in order to always have at least ensure this desired state. But to just host your application in cloud environment in cloud or in public cloud or private cloud or hybrid cloud environment, you need a very dynamic and very immutable infrastructure. And without automation, of course, it is not possible. So there comes exactly infrastructure as code, one of the very important pillar of cloud native. But the question is, why do I have to use it? So as you can see on the right side of the slide, so first of all, the infrastructure as code concept helps you to provision or deploy your whole cloud native application infrastructures, but as well as manage your cloud native applications lifecycle in an automation way. When we talk about automation, the first thing that comes to mind is faster. It means that you can deploy, you can manage your application lifecycle much faster in automation way. And the next one is a consistent result. What exactly does this one mean? If you just run the same script, the same code, and the same immutable infrastructure that you just define in a declarative or imperative way, you are going to have always the same result and the same consistent result. So, and as well as you can just manage, of course, in multiple environments. For example, the infrastructure as code frameworks like a Terraform that supports you, that you can just write the same script that you're, or within the same configuration script that you're defining your resources, and you can deploy too many or too many cloud providers or too many in environments. But of course, from regarding of syntax, it's going to make just be different. But you have the option to deploy too many providers. Either it could be cloud environments or on-premise environments. But we are going to see about that in next slides in much more deeper way. Repeatable usage, it means, so when you just compare the infrastructure as code concept with the usage of the manual ways, it means manual way means when you're just deploying cloud resources on Azure portal. So just imagine the use case, or suppose when you wanted to just deploy a virtual machine for one person, for one developer on Azure portal, how long it's going to take, or maybe around 3, 4, 5 minutes, it's okay. It's not, maybe in infrastructure as code deployment will take around that or a little bit with a very small difference. But whatever, when you just deploy a single virtual machine for a whole team, for each developer of that, it means you're deploying the same virtual machine, actually with almost same configuration to the whole team. You're doing for the whole team the same task. That's exactly when it comes to one of the biggest usage of infrastructure as code, that you are defining a script, you're writing code, and you're executing this code. It means each time that you need the same resource for someone else, for another team member, you have to just deploy, or you have to just with very many changes to change it and deploy it again. The last one, of course, because you're writing code, it's like a text writing code. You can use it. You can manage it with a version control system, either GitHub or Azure Repo or any other version control system providers. And last but not least, because you're writing a code and script, it's automatically, without any extra approach, without any extra task, it is just a documentation, which is very important. So with that, let's look at as a little special about which infrastructure as code frameworks are available in Azure. So in Microsoft Azure, which infrastructure as code supports. Let's start from the left side. So the first one is Azure RM, RM template, so Azure Resource Manager template. So this is the first infrastructure as code in Azure, in Azure Portal, or generally Microsoft Azure Cloud. So it's basically a template with written in JSON. It means you're writing code in JSON language or in JSON language in what you want to deploy. So you're defining your desired state of your application or your cloud infrastructure in JSON base. It's restricted to Azure because you can only use to deploy inside Azure and not any other cloud providers or not any other environments. The next one is Bicep. So because the JSON is a little bit complex, it's use a lot of functions, a lot of variables, and etc. So for deployment of a single cloud resource, you need a much more line of code. It makes your cloud environment, you're managing your application, cloud native application, much more complex. Therefore, it comes the idea of the Bicep in Azure. So the Bicep just brings its own domain-specific language instead of using any JSON or YAML-based language, which might just make the code much more human-readable and much more simple. It means we're going to just see a comparison between the RM template and Bicep, which you're going to see you're writing much less code for the same desired state, actually. And the third one is Ansible from Red Hat. So, this is from Red Hat, so the company Red Hat. It's as well cloud agnostic. It means that you can use it from many cloud providers, from many environments, and it's YAML based. So, and it supports multiple languages. Called, it's clear, basically multiple programming language. It means for developers, or it's very important, or it's very interested. So whenever a developer has to deploy or just cover infrastructure as code or cloud infrastructure tasks as well, and he or she don't have to just learn any declarative or any imperative language to deploy the cloud infrastructure. He or she just can use his or her favorite language, with Java or C#, etc., to deploy their cloud infrastructure as well. And the same concept is with Pulumi. The Pulumi is becoming in recent years very famous as well, just because it supports many normal or just object-oriented programming languages like Java, C#, JavaScript, etc., but as well as some other programming like Go or Rust. About Rust, I'm not sure, but Go definitely, that you can just writing code with these programming language to define the desired state of your cloud infrastructure as well as your application lifecycle. But the difference between Pulumi and Ansible and Bicep with Terraform are, so just high level regarding of infrastructure as code, there is two different concepts. So one is declarative and one is imperative. So the Pulumi and the Pulumi is imperative because you have to define step by step what exactly you want to deploy. For example, if you want to deploy a virtual machine, you have to just write like object-oriented programming language. How should this resource deployed in your environment? Rather than on declarative approach like a Terraform, like Bicep, etc., you just define the desired state of that resource, the desired state of your cloud infrastructure, how it should look like. Exactly the same way like in Kubernetes that you define the desired state of your containerized workload, how it should look like. And last but not least, from without EPC, so the Terraform, it is the most common used infrastructure as code framework. It's the open source maintained by HashiCorp, and it is a declarative approach as well. It means you're just defining the desired state, and it uses its own language as well, similar like Bicep, HashiCorp configuration language. And it's because it's an open source, it means you can use it through many cloud providers, but as well as support any other API providers or any SaaS providers, like for example, Datadog or Grafana. The last part, so these all the most common used infrastructure as code in Asia, but the last one, so as you can see, for example, Chef, Puppet, Azure CLI, Power options, of course, you have as well. So, but the most used at the moment are Terraform, Bicep, and maybe for some developers going to use the Pulumi as well. But sometimes they are going to be used in combination as well. For example, because Chef and Puppet is our configuration management tools, it means you can combine, for example, them with Terraform. You can provision, deploy a virtual machine with Terraform, and configure it with Chef or Puppet, for example. Or the same way, for example, you can deploy a virtual machine or a Kubernetes cluster, whatever, with a Terraform and configure it with Ansible. So because Ansible and Chef, Puppet are infrastructure configuration management tools. So these are the all options that are available, but in today's event, we're going to just go deep dive only in two frameworks, so the Bicep and Terraform. With that, let's look at now the Terraform. So what it is. So as I said, it's an open source infrastructure as code framework for provisioning or for deploying your cloud infrastructure, but as well as managing your application in Azure or any other cloud provider as well. So it's because it's open sources, it means you can use it. You can use through many cloud providers, but as well as on-premise and many other SaaS providers like Grafana, Datadog, or in infrastructure like Docker Kubernetes, and like MongoDB, etc. And it is a declarative approach. It means you just define the desired state. You just say what you would like to have. You don't have to define a step-by-step instruction. It's the task of the framework that you do for you. And Terraform has its own configuration language called HashiCorp configuration language, which is going to use how to define your resources or how to write configuration files or your scripts. And that's the biggest benefits of the Terraform, that you can use hybrid, so on-premise with the extension of the cloud, public cloud, but as well as through multiple cloud providers. That exactly it means you can have a single script, a single configuration file in Terraform, and you can define 3, 4, 5 cloud providers or any provider, for example, AWS, GCP, Google, GCP, Azure, and any SaaS provider within single configuration file, and just deploy your resources to all these providers. But of course, the big difference would be that all providers don't have the same syntax. That's exactly what it means, and not write once, deploy anywhere, because it is just obviously that the GCP Kubernetes won't have the same syntax like the EKS, for example. But within single configuration file, you can define many resources from many providers and deploy to many cloud providers. And it supports the state management. State management in Terraform is going to be used to show or to represent the actual cloud infrastructure environment. It means whenever you deploy or apply your configuration, whenever you apply a resource in your cloud environment, in a state file is going to be store all information about this deployed resources or about all these deployed resources. The last one, so in order to have the concept of repeatable use, in order that you don't repeat your work, your task all the time, therefore it's very helpful. It supports Terraform to use the concept of modularization. For example, whenever a company has some resources that always should deploy them with safe configuration. For example, a company wants to have a storage account, and the storage account should always be with Europe, and always should be has an account replication type of zone storage, and it should support it, etc. You can just define all of these configurations, these all general high-level abstraction of for this company. And whenever you need, whenever each team member is going to need this deploy this storage account, you don't have to define all resources, and it's just enough that all modules. You don't need to write the whole code for the whole resource again. So we understand now what Terraform is and how it, which features and which concept it has and which features it supports. Now, how it looks like the workflow of the Terraform. So basically, there is always three command line, command line up from the Terraform CLI that you are going to use all the time. So the first one is the Terraform init. It means whenever you created a repository, whenever you created your first Terraform configuration files, you're defining, you're writing code, what resources you want to deploy in your cloud environment. And after you finish writing your code or defining your resources, the first step is init. So Terraform init. It basically initializes your root directory. It means the Terraform basically relies on providers like Azure, providers like AWS, GCP, and many other SaaS providers. With initializing, you are going to download, or the Terraform going to download all these provider plugins and initialize your working directory. Next step is the optional step to plan. With Terraform plan, you're going to create an execution plan. It means it's just for you. Therefore, it's optional, so you don't have to basically do that, but it's very useful. So therefore, most of the time, it's going to be used that you create an execution plan for yourself in order that you can just access later as well. Whenever you just store it in a file, that you can see what exactly you executed in this specific time. And the third step is the apply. So it's mandatory. With Terraform apply, you are going to just execute what exactly you created in the recent step in the plan. And the last one is whenever you want to destroy, whenever you want to delete your resources, you are going to automatically destroy it with resources. So in the state of plan and apply, it's going to be stored your real representation of your cloud environment, or to say better, the state of deployed resources in a Terraform TF state file. And this one exactly use the Terraform for the comparison. So what exactly is now deployed and what exactly is now in configuration file. We're going to see that in next slide in a very flow diagram. But before that, so I often just mentioned that the Terraform is open source and it's cloud agnostic, or you can use it through many cloud providers and many other SaaS providers as well. Here is just an example of some providers that Terraform support, but at the moment I think it's more than 250 providers basically are supported. So from on-premises to SaaS providers to biggest cloud providers, it is this one. So here's a little bit more description regarding of Terraform state file. So as I said, the Terraform state, the Terraform.tf state file is going to store the actual state of your deployed resources. So whenever you deploy any cloud resources, the Terraform is going to store all these information about the deployed environments in this file. And this file has just a sensitive information because it's everything. It stores everything about your deployed environment. Whenever you just deploy, for example, an instance of a SQLDB or MongoDB, and this MongoDB or SQLDB going to have an admin username and admin password, etc. All these information going to be stored as a clear text in this file. So before that, how regarding of remote state and local backend or remote backend, so how it looks at the flow. So first of all, you're creating a file main.tf. You're defining the resources that you want to deploy in your environment. So whenever and then Terraform going to read this file. So first of all, it's going to check is there any state file? No. Then it's going to read the main.tf, and then the next step is going to check the state file. So is the resource that I want to, or the resource the user want to apply now, is it already in state file? So is it already in my cloud environment? If there is, the Terraform would say, hey, your cloud infrastructure represents the same that your configuration files. If it's not in a state file, it means Terraform going to try to deploy it just newly. And the same concept is for if you want to just update your configuration, if you just want to delete, so basically the CRUD method. So I mentioned already regarding of Terraform state file, it stores just sensitive information. So whenever you're using the Terraform local on your computer, when you deploy some cloud resources in your cloud environment, a file we're going to be created directly called Terraform state. So this one contains all this sensitive information about your environments. And this one is called local state because the Terraform TF state file at that point exists on your computer machine and on your local machine. But this is not best practice because, as I said, it just stores everything about your environment, every kind of sensitive information. Therefore, the best practice is a remote backend. Remote backend means that you are just you're going to store this Terraform state file in any remote environment. For example, in block storage. And block storage brings, from security point of view, many benefits. For example, you can use RBAC, role-based access control. It means you're restricting the access on this CE file. There's no, not everyone can have an access on this file. Or you have the disaster recovery option benefits, because the storage account is at risk to encrypt it. And this next one is you can choose a storage account in which availability options you would like to use. For example, do you want local redundant storage, so it's going to be stored on only a single data center, or zone redundant storage? You want to just have in multiple availability zones, so in 3 availability zones, or you want a geo redundant storage, which is going to be stored in many data centers far away from each other. And it's, of course, it supports the collaboration. It means whenever you store this Terraform TF state file, and other member of the team would like to deploy the same configuration, the same cloud environment they would like to have, then you just download and run this TF state file local, and going to have the same environment as well. So with that, enough theory about Terraform. Let's jump to the code a little bit and look at the demo regarding of Terraform. So Martina, I hope you can see my VS Code. Cool. So this is just a local machine. On my machine, I have just created a directory, and I just structured like 2 different subdirectories, 01 and 02. But it's just a question of how you structured your project, how you structure your directory. It's not something special. So the first part, you're starting Terraform always with the main TF file. So the main TF file, and the first thing that you are defining the provider. As I said in the presentation part, so Terraform relies on providers. It could be a cloud providers, it could be in SaaS providers, but without any provider, Terraform can't work, because the Terraform going to just call the resource that you want to deploy from that provider. So therefore, in the first step of the Terraform file, we're going to specify the provider version and the provider feature. So in our case, we're going to have the Azure RM, so Azure Resource Manager API, because we would like to have deploy some resources from this provider. Please. Yeah, sure. How it looks like. So in the first Terraform block, you're going to just specify which provider version you would like to define from Terraform HashiCorp registry. So the Terraform registry is just a database which locates the whole information about all supported providers that's maintained from HashiCorp. In next step, you're configuring the provider. It means in our case, we want to select the Azure RM, so it stands for Azure Resource Manager API, and we are configuring that one. And next step, you're going to start defining which resources you would like to deploy in your environment. So in our case, we are going to first start with a resource group. Defining a resource group, and Terraform always starts with keyword resource. That's the keyword that belongs to HCL, to the HashiCorp configuration language. It means you can't change it, so it's just static. The next one is from Azure RM resource group. That's just a reference, just the name of the resource that you would like to deploy. You can change this one as well. The last one is a reference name, or a symbolic name. It's going to be used for referencing between 2 or more resources. But this one you can change it. You can just name it whatever you would like to have. So each resources have some mandatory properties and some optional. In our case, regarding resource group, so you have to at least just define 2 of them. So the name of resource group and the location. So properties you can just define. You can just supply value to properties of resource group via default. It means you're just writing the hard coded. Like for example, in this case, could be you can just write the name of resource group, something like this one, let's say, energy for resource group reactor. But it's not best practice because you're just writing the write off the resources and any kind of sensitive information, etc. as well, hard coded. And it is whenever you would like to have, for example, there are some properties like location, you're going to use this in many resources. So it means each time you're going to just define right in each resource. Therefore, the best practice is you should use the variables, which variables you don't have to supply the values each time hard coded in each resources. You're just defining one variable, and you would like you can use it through many resources. So these variables are located. So the variable resource group and variable location, etc., are located in a separated file. Here is a call for variable.tf. So therefore, for example, the variable resource group, it has at least the type of the variable. So it is a string, it's a number, it's an integer, or a number, or it is Boolean, or it's an object type. So just a mix of everything. So the object would be just a mix of a string, integer, a Boolean, etc. And on top of that, just as a test, you can define as a two-line of validation that you, for example, in some cases you would like to have just a condition. You would like to have the resource group name should be definitely bigger than 6 characters. And the substring should always be between 0 and 3, and it should always start with RG. Because in many cases, some companies or most of the companies have a very specific prefix for resource group, for subscription, or for naming convention, etc. And you can just push, you can just define these kind of prefix or these kind of naming and convention to just validation and contention. In the case that it doesn't, for example, the user of the writer or the author of the code doesn't observe, doesn't write that correctly, it's really just write an error message. So exactly in the same way, we are going to define our other variables as well. So I'm not going to explain each one of them. So it's the same way for location, the same way for storage here as a variable, storage application type, and container name. The container name, which is going to be deployed inside that storage account. I'm going just back to my main case. So I have the storage account, resource group name, location, and tag. The tag is optional, but I would like just to use this. And next step, in next resource, I'm going to define it as a storage account. So in the storage account, so as I said, it starts again with keyword resource, and then it has some mandatory properties, and we would like to use for them as well as variables. For example, for location, we have storage tier and replication type. But what is this one? For example, the storage account needs a resource group, and I just routed HRM resource group RG name. This one is just association between two resources, because as you can see, that this name is coming from line 16 from Azure Resource Group, and the RG is the symbolic name, so because I want a reference on them, and I would like to just access on the name of that resource group. It means I'm creating this step as an association or a dependency between storage account resource and my resource group. Why I would like to do that? Because a storage account has to be deployed inside the resource group. It just to make it clear for Terraform that Terraform is going to understand. So I have to deploy first of all a resource group. The next step, I have to create a storage account, because normally the Terraform use the concept of parallelism. It means the Terraform always try to deploy all resources that you're defining in this main TF at the same way in parallel. But in the case of it, you're defining such an association, such a dependency between many resources, then the Terraform will just look at, okay, first of all, I have to create a resource group, and the next step, etc. So what does local mean, for example? Because there are some kind of resources, like, for example, a storage account or a container registry, etc. They need a unique street name. For example, storage account name should be in all worldwide inside Asia should be unique. So if you just write the name of storage account as a variable, and when you're defining the value of, or you're supplying a value for that storage account, for example, you're just thinking STT account 1, 2, 3, 4, 5, 6. Most of the time, it's going to be a Unix string. And it is just time consuming. Each time you're typing any name or just any name, you're hoping that this could be unique, but most of the time it won't be. Therefore, there's a concept of local variables in Terraform that you can create a unique string automatically. For that, I am creating, for example, in this case, a unique string. In this one you can find here, so it's this code block calls locals. And inside this code block locals, I can create many local variables. In the first case, I'm creating a tag because I would like to create one-time tag and going to look use too many resources. So just use the concept of reusability. And then I'm creating a storage account name as a unique. So I'm going to give a prefix. So I'm saying I would like to have my storage account always should start with STG account and class random integer and the result of this random integer, and where it counts as random integer from this place. So I'm creating just a random integer. It should be always 5 characters. What is it? 6? No, it's 5. So it should be always 5 characters. It should be always between 10,000 and 9999. So it means my storage account, every time that I would like to create my storage account, it would always start with STG account plus 85 random number. And in this case, I'm damn sure the storage account would be always the same, a unique name. So let's look like next step. So the storage application, storage tier and location, so just come from the variables. And the next one is defining the third resource that I'm defining, creating with Terraform is the container that I would like to create inside my storage account in the same way. So before I'm just getting to other files, I'm going to just deploy this one. So as I said, so in first step we have to initialize our working directory with Terraform in it. But first of all, I have to go in the right directory, directory C1, and then I'm going to just initialize Terraform in it. Right to work correctly. In it. So as you can see, it's already initialized in the backend. It means the Terraform now going to create. So as you may just saw it, there comes a directory or a subdirectory called .terraform. If it just opens, you're going to see in next minute. So I have an error. Error returning keys. I have a storage account. I just second, please. Where's TF4 file? Yeah, sorry. I just forgot the file that I should supply the values. I'm going to just explain it why it's exactly missing. TF4s. Yeah, this one is missing. So, and so what exactly is missing? This is Terraform TF4s. So we defined our variables in this state. So we have the variables like storage account, and storage tier, storage application type, and locations. But where did we define the value of these variables? We didn't supply the value. You can supply a variable through 6 ways. You can define it on command line. Whenever you're deploying, you can just give it on the command line. You can create a file. It's called Terraform TF4s. In this file, you're going to just write the name of the value, the name of the variable. For example, in our case, our first variable was resource group. It means you're writing the resource group name, and then the value, the name of that resource group name. For example, in our case, we're going to have just resource group Terraform. And exactly in the same way, next variables, for example, location, and then I would like to deploy this one with you. And next variables is, for example, storage tier, storage application. Storage application, I would like to just define ZRS, zone redundant storage, and storage here. It's going to be, for example, a standard. There is a different kind of storage. The storage 2 is standard, and it is fast. And the last one is, I think, the container name. So in this case, just container name, and I would like to just call it my container. So as you can see, so I have my variables, and I have all the values of these variables, and I have a main to give all resources that I would like to deploy. Whatever that I would just try it now. I hope there isn't any file now. But during the time, so I'm creating the resource group. Oh, sorry. Of course, it's failure because I defined as a variable resource group, but it's just it looks like a string. So now, next try. Still. Could not. Resource group Terraform Reactor could not find. But I didn't choose this one. Let me just check it. But anyway, I have already tried this one in before the session, before the event, and I have already finished this as a demo. So I would just like to take it from my repository and that I have. So this one is here. Where is that? Copy. Terminal. CD. Repo. I know it's okay here. Why? Get clone. So now it looks good. So CD Terraform Reactor, and then open this one in full in this window. Open folder and documents Terraform. So it's again the same repo, the same example. I'm going to just do one. This one Terraform image. So now it looks good. Sorry, I didn't know what exactly was with the before demo. So it's just the same file, the same repository that I tested before the event. So everything's the same, so nothing has changed. So I have just initialized my directory. As you can see, initialized in the backend, and then you're going to just get the message Terraform has successfully initialized your working directory. So as I mentioned in the presentation, I want to hide one. No, not the code. Okay. So Terraform plan. So the next was we create an execution plan. So container name. Why it didn't take from here? Because this file is missing. Sure, it's a correct file error. And copy from here because I have already this one. So now one. But during the time that this is showing. So as you can see, the structure of my project, I just have a file local TF for my local for creating a unique string name, for main TF, output TF, and variable TF. So basically, the Terraform don't have any don't differentiate between all .tf files. So you can just create you could just have a one single file and just put all variables, all locals, all main TF in within a single file. But just regarding of to have a good structure, good project structure, it is best practice that you just separating the variables from locals and the output in the main TF, all resources. The next step going to be Terraform apply, and I'm going to just create it with auto approve. So it won't ask me for confirmation. And then it's going to be started to deploy these resources that I defined in my main.tf file on my cloud environment. But as we've already saw, so there comes the new file, it's the Terraform state file. So whenever the appliance is finished, so you can see now the Terraform stores the actual state of all resources that I deploy in my cloud environment. So I'm not going to just wait until the deployment is finished. I'm going to just look at on portal if some resources are already there. So we just call our resource name resource rg minus Terraform. And let's check it that resource group. So there is a resource group already there, but the resources inside this resource group are already still deploying. But now it should be the storage account there. So refresh. Once again. Refresh. Once again. So I do any error? Actually no. So you were going to just get the confirmation message that the 4 resources are added. Your resources are successfully deployed. So now actually should be the resources already there. Why? So now there is this storage account. So basically the resource group is in itself is a resource as well. So resource group, I just call it a resource RG Terraform, and inside that resource I created my storage account. And as you can see, the storage account name is unique as well as I define as a local, so STG account, and then any 5 random integer. And inside that storage account, if you remember, I created a container as well with the name of my container, with my resources. So with that concept, with that way, you can just define all your cloud, your all application, for example, a 3-tier application or your whole cloud environment. You're just defining variables. You're just defining your resources. For unique topic, you're just creating your locals, but as well as for repeatable things, local variables. And you can have optionally output as well. For example, the output, the ID of your resource group on your command line, etc. In the same concept is for Terraform modules. I'm going to just show it as well. The Terraform modules is basically you are just grouping many resources. It means whenever you have to create or you should create a storage account often a time or often of your storage account, you're just grouping this resource. And this could be, for example, inside of Terraform, inside of your directory, you're going to have a separated of modules. And inside that modules, you're creating modules for that specific resource that you would like to have. For example, the storage account for VNet, for virtual machine, etc. And in our case, it's going to, for example, we're creating a module for a storage account, and inside that module storage account, you're defining that resources with all its high-level abstraction related properties. For example, the name, resource group, location, account here, etc. And the next part of variables, because you're using the variables there. And outside of that model, you have your main tab. This main tab outside your model is basically your initial point of you are getting in touch. So inside this general main tab, you're not defining your resources as usual, what you just did in the recent step. You're just calling that model that you would define the recent step. For example, it's exactly this place, between line of 23 and 13. So in recent steps, you define a resource with a keyword resource, just as a new resource. But in this step, you're not defining with a keyword resource, a new resource. You are just calling the module storage from source, from local environment, from your local project directory, from a folder modules, from a storage account. And with this way, you don't have to define all properties of this single resources in your main tab, your general main tab, or write all code again and again in a repeatable way. In other words, the deployment of this module is the same way. So the same workflow. First of all, you initialize the backend of this module, and then you're creating an execution plan. And then the next one I'm going to apply, and the last one that you are just destroying your infrastructure. So as much regarding of Terraform, and with that, let's just jump to the bicep. But before I jump to the bicep part, is there any questions from audience here about Terraform? Sure. Sorry, I can't hear you. Sorry, no, again. Yeah, I'm going to answer. So for the people in the audience in virtual, sorry. So I hope you can still hear me. So the audience asked me if there is any way to just deploy within single configuration resources to many providers, correct? Yeah. So as I said in presentation, you can have a one main TF and you can deploy the resources to many providers. But of course, you have to configure that provider as well. It means within that main TF, you have to, if you just suppose an example, you would like to deploy a virtual machine on Azure in GCP. It means in your main TF going to be look like you have to define Azure M as a provider, as a resource manager. You have to configure the GCP provider as well, and you have to create a resource virtual machine from Azure. You have to create a resource virtual machine from Google. With that, you are going to create within single file, deploy that virtual machine, that resources through 2, 3, 4, 5 providers. But the syntax of them, of course, is different because the syntax for a virtual machine in GCP is different in syntax of a virtual machine in Azure. Answer? The Ansible and Pulumi, as well as cloud agnostic, the same way. But again, the syntax of them will going to just be different. Yeah. Any other questions? Okay, seems not to be so because of the time. Just look at jump to Bicep. So as I said, Bicep is just the next infrastructure as code implementation option in Asia. It just came as an alternative, not as an alternative, but just a better solution for RM template or RM JSON template because it brings its own domain-specific language. It's similar, like a Terraform. It's used just a declarative approach. You're defining your resources, as you can see in the slide. Sorry, I just put the presentation mode. Now it looks good. So the Bicep itself is just a domain-specific language, and it's similar like Terraform. You're going to define in a declarative approach the resources you would like to deploy. And it's Azure native. What does it mean? It means it's a framework that you can use only for Azure, for Microsoft Azure deployment, and not to other cloud providers or any SaaS provider. You can use the Bicep only within Microsoft Azure deployment, and that's it. But it has some benefits as well. Why it is Azure native? Because it means because it's the Azure native framework. It means as well as that you can define all preview resources and all new release resources suddenly with that framework as well. Other side with Terraform, for example, you can't deploy a new release or a preview modus cloud services because it's going to just take a time around 3 to 6 months until the Terraform just maintain that resources within their registry, within their provider on their registry. And it don't have any state management because that's one of so some companies say this is a drawbacks of Terraform that it has a state management, and state management just store the very sensitive information. That is the benefits of the Bicep, that they don't have any state management. So now the question is how compare Bicep the real world representation with the configuration files. It is a portal, Azure portal. It means whenever you would like to check if your deployment, if your code definition that you just deployed, it is really deployed on Azure portal or no, you have to just look at on portal if your resources are deployed or no. There's no state file that you can see So this is the actual state of my deployment. Exactly on the same way, like the Terraform, it supports a concept of modularization. It means you can just group many resources, or you can just group a resource that you are going to deploy often, or often, and then you can just group them as a module and call in your main configuration file, rather to just write all resources again. And the last one is the looping condition. It means you can in Bicep, similar like in Terraform, you can have a looping condition. For example, suppose you would like to create a storage account, 3 storage accounts to 3 different regions, or 3 different teams, etc. So in this concept, you can just use a loop condition. So you would like to define 3 different storage account names, and with this loop conditions, it's going to choose every time with the index different names, 3 different storage accounts. Because we talked, so the Bicep is just a better version of the RM template, but so it's not a JSON template, it's a Bicep template. Here's just a comparison of how it looks like. So for example, so on the left side, you can see a single SQL server, single SQL server and SQL database instance going to be deployed and written with Bicep. And at the right side, you can see the same resources deployed with the RM JSON template. So it's much less code, it's much very human readable and very simple syntax rather than RM JSON file. With that, we are going to just look at very quickly the Bicep demo as well, how it looks like. So this is my project structure. So that's my repository that I would like to have. So that's the that I would like to define resources. So just another kind of the rather to Terraform, you don't have to define any provider because Bicep is only for Azure. So you don't have to define any provider. You're just starting defining your resources. So in a resource in Bicep, it always start with similar like Terraform with keyword resource, and then the resource name, and then a reference with API version of that resource. For example, the Microsoft storage and storage account, and which API version of that storage you would like to use. In the same way, for example, Microsoft.SQL Server, and which version of that SQL Server you would like to have. And then all mandatory properties, or all optional with some optional as well. For example, storage account need definitely a name, a location, in which storage account type, and storage SKU, etc. So this one is the name, the property, and what is this one? It is the reference. It's similar like variables in Terraform. So here calls it parameters. So in Bicep, you have the concept of parameters and variables. So you have two different way how you can just define or supply values to the resources property. You have the parameters. You can use this. So basically, both of them just do the same task, the same work, but there's just single or a very small difference. So you can use the parameters for the values that should be different through many deployments, and you use variables for the properties that the value of them going to be same or static through many deployments. In a parameter definition, just start with keyword param, and then the name of them and the type of them. And if you would like to have as a default value, you are just writing with equal. But if you would like to have defined through many, you would like to create a parameter or JSON. So this one just contains the parameter name and the parameter value. It means you are going to similar like the Terraform key parse. So this parameter JSON is the equivalent of Terraform key parse. You're just in Terraform calls it variables, and here calls parameters. So it's defining or supplying value to all your parameters. For example, in this case, app service plan has a SKU of F1 and a tier of 3, or app service plan has a count of 1, because I define all of these app service plan, instance count, app service plan, SKU, etc. all in my main.bicep file as a parameter. You can find them, for example, storage account here, app service plan instance account as an integer. Therefore, it's called here as an 1. So I would like to just one instance of that one. And the same concept for the client is queue. So you can optionally you can just assign a description for your parameter for what is going to use, or you can just use some functions like min value or maximum value of your instance. You can optionally just assign like environment variables, for example, in which environment you would like to deploy this resource. For example, you can just give optionally in depth test prod, and you are going to on command line going to ask in which environment you would like to deploy this one. So these are my variables, and variables are just a little bit different from, but it is the same concept like a parameter. So it's to start with a keyword var, and then the variable name, and then the, for example, I define in this case just as a conditions storage account SKU name. If my environment type is production, then I would like to have the standard GRS, a standard geo redundant storage. Otherwise, I would like to have just LRS. Yeah.
Because we're running out of time. So can you wrap it up in like a minute?
Yeah, definitely. I have just sure. Sorry, I have just one final slide. So with that, it's just you define the resources, and with the command line of the easy. With the command line of the easy deployment group create template file. So because you would like to deploy this template file main bicep, you're deploying this resources or these bicep file in your environment. So I'm sorry regarding of the time. Therefore, I won't just deploy this resources because there's no any magic to how to deploy it. With this command, it's going to you would like to just deploy it in your environment. But if you are interested, I can share the repository with you. Therefore, I'm just going to jump to the last slide, which is maybe very important. So now, last but not least, what is the difference? So on the Terraform side, the benefits are because it's open source, it's in cloud agnostic. You can use it through many cloud providers, and it's a very biggest benefit, especially when you're just using many cloud providers or your company's strategies. So you have infrastructure services, or generally you are all distributed through many cloud providers. And it's hybrid and multi-cloud, and it has a state management. So state management has the benefits as well because you have something that you can compare your real world with your cloud infrastructure. On a contra and drawbacks of the Terraform is that whenever I create a new resource, a new cloud services, or a new preview modus of services, it's not available. You can't just deploy with Terraform. It just takes time, around 2 until 6 months, until Terraform just maintain, until Terraform just take in their registry in their database. And for example, regarding of CI/CD pipeline, you can't, for example, you need definitely an extra task, etc. So basically, the summary, you can use the Terraform. It makes sense, or it suits very well for hybrid multi-cloud environment. And on the other side, if you're just using Azure as a cloud provider, then it makes sense that you only stay on the biceps side. But of course, that's some restriction as well. You can use, for example, to hybrid cloud or multi-cloud, or because it's only suitable for suits well for Azure-related tasks.
Sorry for interrupting you.
So no problem. Sorry. Is there a question?
Yeah, you can give questions in the room.
Sure. Sorry.